All righty. Well, thanks for that introduction, Sterling. Those of you that are in here in the audience, how many of you have seen the new weather station that's near the doors to the entrance to breakfast this morning? Just a few? A few, more than a few? All right. If you haven't seen it, please stop by and take a look at it because I'm going to talk about it during this presentation. And this presentation is going to make a proposal that I think a lot of you will be very interested in. So here we are. You've known about this for years. I've been studying this for years. I did a news travel survey this summer, as Sterling mentioned. This is one of the worst ones. This one here in Sandpoint, Washington. Just unbelievable. This is at the airport. Radiators, anybody? Gosh. Anyway. So we published a new book about it, and we collated all of the different stations, did some simple data analysis, and bottom line is now the number from, when I did it in 2007, it was 89%. Now it's up to 96% of the stations we surveyed have issues like this. Not as bad, but many of them have just as bad or similar type problems. Of course, there's all these stations all over the United States. There's the Cooperative Observer Network. The Cooperative Observer Network is run by NOAA and administered by the National Weather Service, and it's been in place since around 1890 or so when the Weather Bureau was formed. And originally it was there for agriculture. Agriculture was the main original focus for the National or the Weather Bureau back then, but it got co-opted. They started using these stations for a purpose for which they were not intended. And that's why they're so bad. They're not really climate stations. Now, each station has one of these or both of these types of instrument shelters. The Stevenson screen, which is highly problematic for maintenance issues because you have to keep it painted, you have to maintain the wood and so forth. And then there's the other device called the MMTS, which stands for Max-Min Temperature System. But I've heard from Weather Service personnel, and I kid you not, they call it the Mickey Mouse Temperature System. Because that's what they think about it. There was one of those, it went to the lowest bidder when it was designed. But both of these things have problems. They have problems with albedo, they get dirty, they heat up, they're too close to buildings, particularly the MMTS because it needs a cable. So what we found is that in 96% of all these stations around the United States, the ones we sampled, they violate NOAA's own published 100-foot rule. You'd think they'd be able to keep the stations away from the encroachment, but the problem is they don't really have control over the land. NOAA, or National Weather Service, doesn't have control over what happens at these places, and a lot of these are in people's backyards as volunteer observers or at farms or whatever, and if that person decides they want to put in a new patio or a bunch of pavers or whatever, they'll just do it because they don't owe anything to the National Weather Service to be able to say, hey, can I put in a patio next to your thermometer? They just do it, and that's why this stuff happens. Of course, back in 2007, when I first started, this is one of the most famous pictures. This is the fire station in Marysville, California. And all of this used to be grass years and years ago, but they turned it into a parking lot, and then they added cell phone towers. The city said, hey, we can make some money. Well, those cell phone tower equipment sheds you see there on the right have air conditioners on it. And I can remember vividly standing there next to the MMTS with hot air blowing on me from these air conditioners. And I said to myself, this is where they're measuring climate? Fortunately, a few months after I exposed this, NWS quietly closed this station. Same thing with Arizona, Tucson, Arizona. At the University of Arizona in Tucson, at the meteorology department. Those doors you see at the top, that's the meteorology department. And they put their Stevenson screen in the parking lot. You'd think atmospheric scientists would know better. Well, the story is that it used to be sited over grass a long time ago, just like all of these things. But the problem is the university kept building things, and they kept having to move the station. And then they finally decided, you know what, we've got nowhere else to put it, so we'll put it in the parking lot out front. Well, that station was closed a few months after I exposed it. So in 2022, I started looking for more of them. Here's one in Wheatland, California. Anyway, this particular station, right next to the rooftop there, you can see the infrared. And is this a good place to site a station next to a parking lot and a roof? No, probably not. but it's been there a couple of decades. Here's one in Idaho. This one really floored me because Arco is a very rural community. I mean, literally, it is in the middle of nowhere. But they decided, hey, let's put it next to this brick building and this car. Works for me. This one here is the most egregious one I've ever seen because it was done by design. The MMTS that you see there circled on the left is above this rock wall. And this was just created a couple of years ago. They used to have the thing over grass, but they put it there. And of course, the rock wall is absorbing all of that infrared or solar radiation, all that, and converting it to long wave. And then at night, it radiates it out and it heats up the sensor. And it rises. It's like the perfect place to bias a station. Here's another one. This one in Grants Pass, Oregon. Now, this one was malicious, and I say this because the Weather Service knew about it. The chief engineer at this station I know personally, and he had years ago complained to the National Weather Service that where you put this is wrong. Can we move it, please? And they refused. I kid you not, and that's why I call it malicious siting. And of course, here's Sandpoint, Idaho. It used to be where you see this equipment on the left, but they moved it to this parking lot over at the airport. And the reason for that is that the Agricultural Experiment Station, which had been running this for years over on the left, they closed. But they had to have a physical person to take the measurements off the MMTS system, write them down, and send them into NOAA. So they put it over at the fixed base operator at the airport because there was a live person there. Simple as that. All right, so we're going to talk a little bit about science. The science of these heat sinks is pretty simple, really. In the daytime, a concrete object like that slab that you see there absorbs the solar radiation. It heats up. Anyone knows this. You know, stuff gets hot during the day. And at night, it re-radiates that as infrared, and that warms the air near the surface, which then, of course, biases the low temperature upwards. And because the low temperature is biased upwards, that changes the average temperature between the high and low also upwards. And as a result, because that's used to track climate change, that is what gets biased. And that's why we see this problem all over the United States. There's an example, a perfect example. This is in Fayetteville, North Carolina. MMTS is right over a piece of concrete. You can see that infrared radiating right off of that thing. So when we look at all of the good stations, the ones that have not been compromised, and literally there's just a handful left, we're just about 125 or so, versus the bad stations that are all corrupted, the ones that are next to concrete and so forth. The blue line represents the good stations, and the orange and red lines represent different variations of the bad stations. Basically, the rate of global warming is halved when you look at just the good stations. Makes sense, right? So, what do we do about this? I've been pondering this for years, and I finally decided we have the power to change this. NOAA's not going to go out and fix all their stations. I've already tried this. They'll fix the worst ones that are embarrassing. But they generally don't care. They say, oh, we can statistically adjust this. You know? You can't. No one knew about this. Back in 1998, they said, we need a better network. And then they had a paper about it. And then they commissioned a design for a new station, and the U.S. Climate Reference Network was born. It went into operation in 2005, and it's been producing data ever since. However, they say, of course, we can adjust for these problems associated with the bad stations. They can't. All these adjustments do, homogenization, is when you get 96% of them corrupted, is smear the bad data around and cover up the good data. You bias the good data warmer. That's the problem. And they don't talk about the Climate Reference Network, the new state-of-the-art network, in any of their public reports. And meanwhile, it hides in the background. The public is virtually unaware of the good data and what it says. Here is a comparison of US CRN data on the left, the good data produced by this new network, versus NASA GIS over on the right. And I'm sorry these aren't to scale, but you can see that NASA GIS is reporting a significant upward trend, whereas the same period over on the left, it's flat, virtually. There may be a slight trend, but nothing like what GISS is doing. And GISS is using all of the bad data. So the idea here, circumvent them by creating an independent network, and that's what that weather station is about. Place stations to get clean, independent data, open architecture, and open access. No need for the government anymore. The government controls all of the climate data. We need an independent set. No need for the data adjustments, trustable temperature data, monthly publications of this data, and open to the public. So, the USCRN is old technology, and the weather instrument technology has advanced dramatically. The costs are much lower today. The station I designed out there to meet and exceed USCRN, $2,000 versus $30,000. So I am introducing the Global Openest Atmospheric Temperature System. GOATS. Why? Well, it's going to get Noah's goat. That's why. It's literally. So here is the USCRN station on the left and my station on the right. And these will have the same kind of features. They'll be well-sighted, triple redundant temperature sensors, fan-aspirated shields, and the accuracy is equivalent, 1/10 of a degree centigrade. And you know, the interesting thing is that NOAA, with the co-op network, they round up all the temperatures to the nearest degree Fahrenheit and then convert them. So there's precision loss and everything else going on. So it's going to be better than NOAA, or at least as good in many cases. It's going to be reporting data every 1 minute with a 10-minute average. And the reason for this is because back in the day when mercury thermometers were there, they were not responding instantaneously to high temperatures. It took them time to warm up. So a lot of the problems that we've got with the new temperature data set from electronic sensors have to do with the fact that if the temperature goes up briefly, you know, for a couple of seconds, those sensors can detect that. And so we get an artificial high compared to what was measured in the past. They're solar-powered, cellular data reporting, and going out to the cloud. And they've got GPS. So if someone tries to steal them, we know where they're going. Plus, we know where they are sighted accurately. And this is what it looks like. And it's got two-way communications. It's got a data logger box that goes out to the cloud. You can get the data. It has the ability to add sensors. It'll start with just simply temperature sensors and maybe a carbon dioxide sensor. But we can add all of the stuff that NOAA uses for the USCRN. So it's open access, reasonable cost, plug and play. If you can set up a home stereo system, you can set up one of these. One person, all is needed. Don't need a contractor, don't need to pour concrete for a base, none of that stuff. And it is deployable worldwide. Well, placement, we'll make sure that these are placed properly. We'll look at Google Earth and so forth. We have a robust system. It'll operate several days in full darkness with the solar panel and battery. We've got maintenance taken care of, and ongoing costs are small, $50 a month or less. And we've got built-in security. All of the things necessary to make this happen. This is a screen capture from a couple of minutes ago of what the data output looks like. And as you can see there, we've got the 3 probes. We've got humidity, and we've got carbon dioxide. And the 3 probes data is automatically averaged. This will go into a cloud database, open access. Anyone can get it for any data analysis they wish. Go prove it's wrong if you can. Thank you. We do need sponsors. I want to say, if any of you want to step up and help us out here, one of these stations costs $2,000, and I will be happy to put your name on it as sponsored by. Thanks for your consideration.
All right. Good morning, everyone. I just hope that my slides is up, please. Well, in any case, I want to talk about following what Anthony has said. Excuse me, is my slide on? Okay, thank you. Yeah. I'll be speaking on global warming and what do they mean by global warming as using all the thermometer data that is somewhat not good. And then we will try to explain whether the interpretation of this warming is either mostly human caused or mostly natural, which one is it, right? And my name is Willie Soon. I'm a scientist at series-science.com. Before I start, I want to acknowledge my two colleagues from Ireland, Dr. Ronan and Michael Connolly, for helping me put together this slide set. First thing is about IPCC, obviously, right? They make a lot of claims. But as you can imagine, from 1 to 5, right? Global warming is there, is warmed by 1.5 C or 3 degrees Fahrenheit, so on and so forth, and it cannot be explained by the sun, so on and so forth. And then, but the obvious one is basically claiming that the contamination of the thermometer data, let's say by urban heat island effect, is less than 10%. Those things are open to challenge, and you can prove them wrong by just even turn around. I mean, that's how simple it is, and that's why it's embarrassing for IPCC to make that kind of claim. But this is how they try to tell everyone that, you know, if you look at the data set, right, the solid line is the observed temperature record. Never mind what it is, we'll explain later. And then they say that if I were to try to simulate in computer climate model using only volcano and the sun, which is the green lines, well, it won't fit. If we add CO2, it fit. Problem solved. Everything's done, so let's all go home and stop the funding, right? So I'm going to talk about this subject matter. It's quite a lot to cover in 20 minutes, obviously, but then I hope you understand that you don't have to rush, and somehow the website doesn't appear, but please, you can get all the slides at series-sign.com/post/ICCC15, okay? And we will actually speak about all these issues and clearly shows that IPCC is beyond, you know, good standard of science. The first stage is I want to talk about the history of how global land temperature is constructed. There are 6 stages. The first stage is basically the simple stage from Vladimir Köppen and Edward Bruckner and even Homer Clue from US Weather Service, asking a very simple question: does the globe, you know, the climate change? I mean, the answer is obvious. Climate does changes, right? And then second stage is very clear, is in 1930s to 1940s. There are folks like Joseph Kinser, actually also from US Weather Service. They clearly started to collect all this data worldwide based on the Smithsonian weather records. And they found that, yeah, the globe seems to be warming. And then there are guys from England named Guy Callender. By the way, he's Canadian also. And he realized that, wow, this could be all blamed by rising of carbon dioxide. And then there are third stage, which is 1940 to 1970s, right? Global cooling, basically. They realized that the warming that they observed earlier didn't continue. The globe appears to be cooling slightly, right? And you can see that one of the effects of the temperature record is basically, by now, a lot of things has been gone into this mix. They've been adjusting and readjusting, and then somehow the cooling part seems to disappear a bit, right? We'll explain exactly in details after that what happened. And then fourth stage is basically global warming is finally here. Let's stop mincing words, and then greenhouse effect is here. This is, of course, the testimony of James Hansen in the hot summer of June 1988, right? Everyone got panicked. IPCC got formed. The world appears to be very, very scared now about this temperature warming that is only like 1 degree, 2 degrees Celsius. I mean, boom, that's 10 degrees right there, hot. Fifth stage. War against climate skeptics, obviously. They say, well, urbanization bias is not a problem at all. The raw data is not reliable, so we must homogenize them. We must adjust them in some way. And then, of course, there's no hiatus in global warming. This is a topic that's been gone over many times in this conference. And then, of course, it ended in a very clear situation where we see a lot of manipulation going on. It's called Climate Gate. Look it up, of course. If you want, we can discuss this later. But sixth stage, science is settled, guys. No more challenge, no more ability to even ask a simple question, how good are the thermometer records? That's what we will do today, by the way. The only reason why I stand up here is that we work very hard. This is a cumulative experience of at least 50 years of learning. Trying to tell you that you can take this message, take this slide, go and talk to everyone, your neighbor. First of all, start with your family, right? Your children, your grandchildren, and tell them, explain to them why this global warming thing is not so clear in that sense. So, how reliable are the raw station records? Anthony has shows you a lot of good example, right? Changes in instrumentation, how you measure them. The obvious one is this step change. There are two types of changes that I think worth discussing. Step change, which is one-time change that have nothing to do with climate, but temperature started to warm or cool, right? And then you have trend biases, more systematic type, like slowly building up of an urban city, right? And those are the effects that is much harder to correct for. But we will start with the step biases. This is one of the examples from Austria, right? Munster station in Austria. It's actually a rural station. From the 1767 until now, they actually have a record that measure outside the window, right? It's about 7 meters up. And then 1980, they moved down to 2.2 meters on the ground. They used the Stevenson screen station that Anthony was criticizing just now. And then you can look at this data. The data from the earlier period was there, and then boom, right? They measure from the old way, and then the new way, temperature start warming up. Those things really need to be corrected if we want to study them correctly. So they are right in some sense that we do have to correct for the raw data, but one has to do it very carefully. Of course, the good system that Anthony just discussed could be also very useful. And then the well-known effect of urban heat island effect. This is very well-known. In the inner city, it's much, much warmer than outside, okay? And indeed, this is a human-caused kind of climate change, really. But it's a local change, has nothing to do with rising carbon dioxide in the sense, right? And this phenomenon of urban heat island has been well known by the English meteorologist by the name of Luke Howard in 1820s. He already realized in the phenomenon in London, right, versus outskirts of London. And then this is one of the prime example. You can see on your left, it's basically Paris and then Singapore. The temperature change there from inner city to the outskirts is up to 5°C, okay? This is way beyond any global warming signal that you are looking for. And then my two colleagues, Ronan and Michael Connolly, in 2014, many people have done this, by the way, but they are the ones that independently do this work. Look at what they call GHCN, which is the Global Historical Climatology Network, right? That is collected by NOAA, looking at the version 3 data, and then looking into US, which has the most stations, 1,200 of them. Separate them into, the rural station, and then the intermediate and the most urban one. And then compare them. Here's what happened. At the top graph, you will see is the urban station, and then middle is basically the rural. If you subtract the two, you can see the net warming trend of 0.5 degree per century. That's a lot. For those who know this kind of graph, this data set already correct for the non-climatic bias called the time of observation bias. If you don't correct for that, it's actually 0.7C. Okay, it's a huge per century. That's a big, big signal. And then one example that they know very well, my two colleagues from Ireland, so Valencia Observatory. In 1867 to 1892, those measurements were way out in the Valencia Island, off the coast of Ireland, right? And then in 1892 to 2001, they moved slightly inland, and then by 2001, they moved all the way 350 meter inland, and then the elevation was up 20 meters higher. So clearly that we have good station history. I want to promote that we need to have that information, okay? And from here, you can see the 4 major changes during this time period. And a lot of them needs to worry about, we need to have a full record of this. So my colleague collected all this data. So we started to propose the idea that why don't we start looking at the rural station? We started to propose something like construct rural island, rural US, rural China, rural Arctic, for example. So that's what we're trying to do here. This is the example of island. And then you can see on your left is the island and then the US rural station. The US station got the most data, so the trend really don't look like the global warming signal that you see. Rural China, and then also Arctic. Arctic is much, much harder. We search very deep. For 4 years, we look for any station history data that is available. No one was wanting to give us or work with us and so on and so forth, but we have success in Europe, so we'll tell you that in a minute. And these are all the stations that we have collected. So what we do is that let's average them and look at what they look like. At the top panel, you can see is the rural station over Northern Hemisphere. Okay, it's completely slightly different trend and structure, as you can see. But if you add urban station to this particular 4 region, guess what happened? You got a warming trend that look very similar to the IPCC kind of curve. Okay, and then Here on your left again, we take all the GACN data and average them to show you that you get this signal that's very similar to IPCC proposed. And what we're trying to propose is that, look, let's consider the rural station only data. And you can see even from this simple exercise, you already prove beyond doubt that the IPCC claim that the urban heat island effects is less than 10% is completely wrong. It's at least 40% right here, okay, from this estimate. And then this is what I mean. Can we actually recover what they estimate? We put some 5 or 6 group of what you call construction of the rural and urban station. This is where the part of the tricks. When they construct this station, they put all of them together, and then you show this warming trend that is very clear, and then we can recover the same signal. What we're asking them, can we look at the rural-only station, right? So, quickly, if we compare these 2 data sets with, let's say, oceans and climate proxy, what happened? This is actually the ocean data. This is the 3-ring proxy. This is another proxy from the glacial length. You can see even from this result, by the way, it's quite interesting to show this result. No one even plotted this out before us. In some sense, it's kind of weird, isn't it, right? But it shows you that actually there's some problem in the thermometer record that they are proposing. So I want to quickly update GHCN, version 3 to version 4, right? And we have, I believe, been working on version 4. Version 4 is not completely dead yet. By the way, the problem still persists. No station history metadata available. But we found a colleague, Peter O'Neill from Ireland, that was able to work with us, and when we already published paper talking about all this problem in the thermometer data. So GHCN data is also similar to GHCN 4, but then a lot more data. They have about 20 to 30,000 more stations. GHCN version 3 is only 7,000 stations, right? But most of the stations are really in the northern hemisphere. There's no data at all from southern hemisphere. And here's one example of what the NOAA results are showing. This is a paper published by NOAA group. The first thing we want to start is the version 3 with the urban and rural, non-homogenized, unmolested. So they showed this temperature curve that looks quite interesting. It's warming straight. And then if you study, well, this is the endpoint, it's important to point out. And then if you were to study the effect, right, of changing from version 3 to version 4, what happened? A lot more station, far a lot more station, the modern period warmer than the version 3, version 4 is slightly warmer, and then the past cool, okay? So it looked even steeper. And then very quickly, if you look at the effect from without homogenization, the version 3 to version 4, there's much smaller effect. But the main effect here is basically after you homogenize them, version 3 and version 4 look virtually identical, okay? It shows you the effect of homogenization, and it will explain the problem. There are 2 problems that we will show very quickly. So now, surprisingly, indeed, from version 3 and version 4 is not important at all. Even if you add like 15,000 more stations, it doesn't make any difference, right? From the averaging. But why does the homogenization add warming? That's the key question. And we want to explain this problem, of course. It's called urban blending, so we'll come to that in a minute. But IPCC, NOAA, GIS, and England, they've been promoting this. We must only use the homogenized data, okay? Which is really not a good idea, actually. That's what we want to propose in this talk. So give a quick example of what happened. This is what we did. We actually systematically look at the station history, correct for it as accurate as we can, according to the recorded history. Here's what we found out. This is the first paper we published in 2015. Remember, it's already 8 years, okay? We found out that every time they change this data, homogenize, update the data, every time the recommendation adjustment changes. So 5 or 6 examples here. That is something very fishy, isn't it? Because every time you change, it should be the same. You shouldn't change the record. This is something very suspicious, and we already published this and talked to all those people, tell them to do it. Nobody do anything about it, obviously. Like Anthony said, they don't really care, right? So we need a larger sample. So we studied that one for Ireland, the Valencia Observatory. So now we meet Peter O'Neill. Thank God for Peter O'Neill. You know what happened to Peter O'Neill? He collected a lot of version of their update. Every time they update the GSCN version 3, version 4, he collected. Every month, he have one data set. This is the amount of data that he has, version that he have collected. For version 3, he have almost 1,900 of them. You understand how important this is? I mean, don't even keep them. We have them all. And then 1,800 of them, we got this for version 4. Look at what happened. We are able to publish a paper last year with the whole group of meteorologists from Europe. So Europe, we started to see how much station history we can get. Okay, so this is a very interesting paper. And here the red dot showing the station where we have meta station history. 259 for version 3, 850 for version 4. By the way, it's only 20 to 30% of the total available station. It tells you that we're not able to do this big analysis yet. But the whole point is that we're beginning to have some hope here. So you ask a very simple question. How well is the adjustment? It's only 17% of this adjustment make any sense at all. It's applied consistently. And then if you check the adjustment according to the station history, because we have them, we can show that less than 20% of them agree with actual history because the rest of it is artificial. It's all nonsense. That's why we want to tell you that we have worked on this problem. It's called urban blending problem that is very, very serious, okay? Please look for a minute. This is a very important problem that no one even talk about. No one obviously want to run away from all this problem. To start that, I want to illustrate this simple example. Remember, take a deep breath. You can actually get this slide and study for yourself, but I want to quickly go over this. Imagine this pure world that no global warming, only urban warming. Station 1, we have a station that have moderately warming, no bias, no other bias. Station B is rural, have a step change. Station C is basically similar as Station A, but then it has a cooling bias, okay, in a step jump in 1985. Station 4, very heavily urbanized, like Station C, but then more urbanized. It has a step change. So you look at this step 1. What they do is that they compare, let's say that we want to homogenize everything according to Station A, okay, that is slightly urbanized, right? And then you can see, you compute the difference, and then you can quickly apply the adjustment. This is what happened, the end result. But the question is that, is this correct? We want to illustrate the example that, look at the Station B, which is a very clear example. If you correct this thing correctly, it should be no warming trend at all because it has no warming. It has only a slight shift in the cooling if you should do that. But because you mix it with other stuff, you actually have a warming trend of 0.7 degree, which is really large. It's true, the most urbanized one on the right-hand side, Station D, is showing that the most warming trend from 3 degree is reduced to 2.2. Okay, that's a very interesting, but people keep forgetting the more important problem is the contamination of the rural station. And this is what happened in consequence of urban blending. They are drinking too much smoothie, strawberry and banana smoothie, and they forgot that, you can never get the banana flavor back and the strawberry flavor back. And that's the problem of homogenization data. So please, tell people about this problem. Urban blending is a very serious problem. And here, real-world example, in Beijing, 10 station, published by He and Jia in 2012, and we reported this back in 2018 in our paper, that we show you, if you quantify these 10 stations according to the degree of urbanization bias, very, very urbanized, very, very high warming trend. Less urbanized, low warming trend, okay? And then if you correct for the homogenization, look what happened. The most urban one gets slightly cooler, less warming trend, but it's the rural one all get warmer. This is the contamination process. Again, this is not talk. This is proof that they have problem, and they should admit this problem, isn't it? So what should be done instead? There are a lot of proposals. By the way, we wrote words after word. We published quite a few papers now, and of course, they keep ignoring it. But in the meantime, I want to propose us to look at rural Northern Hemisphere, which is more climatically representative to study the cause, okay? And then we got to study this based on, instead of homogenized rural and urban. Again, remember this curve? We know now the reason why their curve is kind of not good is that because its observed temperature curve is contaminated by urban heat island effect and urban blending, isn't it? But when they run the model, do they get the sun correct, actually? I want to propose to you, obviously it's not correct. This is what happened. This is the basic and embarrassment of solar physics. My apology to all my colleagues. We've been working for this for at least 30 to 40 years now, right? This is the direct measurement from satellite. You put a radiometer up there, you try to measure how much the light output has changed. Just the absolute scale, the difference between the 10 or so measurements that I put here is from 1360 to 1372 watt per meter square. That's a difference of 12 watt per meter square. Doubling of CO2 gives you 4 watt per meter square. It tells you that this problem is not resolved and a serious problem. And the question is this: how do you combine them together? This is what happened that you can do this. You can have 3 options at least that we can think of. The first option on the left is promoted by IPCC. It's called the PMOD, the Swiss group. And the middle one is actually the Royal Meteorological Institute of Belgium. And the right-hand side is called the ACRIM. Each of them will have consequence, depends on which one you pick and how you combine them. Here's the example. You have cooling, and then you get slightly interesting. Almost there, don't worry about it. I'm cool. And then now, here's the thing, right? You look at what IPCC say. They use urban and rural station, and then they use the PMOD data. Obviously, they're right, isn't it? Can we give a round of applause? IPCC win. Now, let's go to ours. Let's propose the rural only. Let's use a cream calibration. Look what happened. Can they say that they rule this out scientifically? I'm sorry, it's nonsense. Goodbye, IPCC. I mean, here's the problem. So very quickly, I only tell you 2 papers out of the 17 papers we published so far from Series Science. Sorry, a little bit promotion of Series Science, okay? Our first paper by Series Science was actually cited by IPCC AR6 in 2021. They claim that we agree with them. So it's an embarrassment for them. Of course, we can easily point out that it's wrong. We actually was evaluating the northern hemisphere snow cover changes. We found that all 4 of them are disagreeing with the climate model, and they say that we agree with them on 2. That's what they're trying to do. They cover up the other 2, which is really not right. And then, just quickly, a plug. Look, halftime. IPCC score 1. Even when we're playing on this slanted field, we score a goal myself, right? Actually, Ronan did it, not me. But we were playing defense all the time. This is the problem. And science has been so bad. If you learn anything, please look at the slide as series.science.com/post/ICCC15. Our funding really comes from people from you to donate and don't tell us what to do, actually. If you trust me, you give me $10 or $100, you'll be helping science, not helping Anthony Fauci. I won't send the money to Anthony Fauci. So thank you very much for your attention. And yeah, please help science and please help support Heartland Institute also. Thank you.
Well, I was afraid that was going to happen. I'd have to follow Willie. And now, the first thing I want to say about, it's funny, we got Anthony and Willie here. They're talking about thermometers. My dad went to A&M, and as a matter of fact, one of his classmates is here today. But my dad's first job was in OBS and Method Research Meteorology at Atlantic City's FAA Tech Center, right? And so in July of 1969, Atlantic City recorded on the 19th or 20th, recorded the highest temperature in the country at 106, which was very interesting since no one within 150 miles of Atlantic City was over 100 that day. And the wind's roaring in out of the south, that, even at the airport 14 miles inland, the sea breeze gets in. Well, what happened was, Dad comes home, he goes, there's no way it was 106 today. I mean, we're sitting there in the low 80s in Summers Point. So you know what he did? He went out there with 5 thermometers, and he found out that the Atlantic City thermometer, while it was fine at 32 degrees, because they used to put the thermometers in ice baths and measure them at 32, the error of the thermometer was increasing as it got warmer. So it was 94 degrees reading 106, and that record still stands today. They won't change the darn record. And I was in instrumentation at Penn State, and I have permanent scars from that class. I'll tell you that right now. So all this stuff gets kind of spooky. Now, the title of this is, I don't have the answers, but I got some questions. It's sort of like, the Festivus thing where Frank Costanza comes out, I got some problems with you people, and now you're going to hear about it. Not with you people, but other situations here. So I got to move the slide here along. Anybody know how to go forward? There we are. It's kind of funny in science. There's two biblical references to me that describe science. Proverbs 25:2 is glory of God to conceal the matter, search the matter out, glory of kings. And then Paul, the Apostle Paul, said, those who know what they know don't yet know what they ought to know. All right? And so what happens is the more you discover, the more you go, holy smokes, I don't really know much. and it has to do with the infinite majesty of the universe. So this was a very interesting situation. This lady, Rebecca Carey, she was a volcanologist at the University of Tasmania. In 2012, she said 75% of volcanoes occur underwater. We know nothing about it. Now that got me thinking, because one of my professors at Penn State, Dr. John Kerr, said, we don't know anything about the oceans. We know virtually nothing. We're not even looking at them, really. All we're looking at is what we see in front of us rather than what might be concealed. So we're in a climate optimum, not an emergency. Quite frankly, it's amazing. It's great to get together at these conferences, but the left these people have actually pushed something that is nonsense and made it, they've taken over the entire idea of the thing. And this is no big deal, what's going on, the warming. I wish it was a big deal because then it would really make me more important, but it's really not. And we have 4 times the amount of people on the planet than 1930 and 1/28 the amount of climate deaths. So what I want to know is if we are in a climate optimum and obviously life is getting better on Earth, how is this such an emergency? Well, life's never been better on planet Earth, so that's all I've got to say, and thanks for coming. I'm only kidding. When your name ends in a vowel, you don't throw in the towel. First of all, got Morano. Is Morano in here? Temperatures, and this is from the Book of Care, John, Penn State. Temperatures are a poor climate metric. Wet bulbs are better. The best are saturation mixing ratios. They refuse to quantify that. Because, I'm going to explain in just a moment. We'll keep moving on. This is correlation of saturation mixing ratio to temperatures. What it says is this, that the increase in 1/10 of a gram per kilogram of water vapor in the air correlates to a 10-degree rise in temperatures where it's very, very, very cold, -40 to -30. You need 90 times the amount of water vapor to do that where it's 75, 80 degrees. So if there's excess water vapor in the air, where do you think the warming is going to show up? So it shows up in the Arctic, right? And I've befriended Dr. Arthur Vitorito, and what happened was, look, here's the problem I have. In what I do for a living, what is going on in the ocean is very, very important to feedback in the atmosphere. All right? And, the Mann-Julian oscillation, for instance, you can watch it oscillate based on the sea surface temperatures and the convergence patterns that go on. It releases all sorts of heat into the atmosphere, bang, it sets ridges up in certain places, troughs up in certain places. So we have to know what's going on. So I'm looking at the sea surface temperatures, and from the 80s to now, they're just warming up. And I'm saying, well, what the heck is causing this? We all agree it's not CO2, right? Not CO2. The sun, I'm going to show you a graphic from Dr. Soon. You could see the water vapor increase moving with the TSI, okay? But you also see something that's happened since the 80s, that there's been an increase in seismic activity, and no one wants to look at this, all right? If you get a big earthquake that goes off or a big volcano, oh, look at this, but most of the activity is going on underwater. So I'm going to go through this real quick. There's a diagram of thermohaline circulation. I hate to tell Michael Mann, but guess what? It's not CO2 that's causing all the warming in the North Atlantic. He won't look. Pretty good argument for correlation and causation in this particular case. This is the increase in seismic activity and the temperature going up. And that puts water vapor in the air, so the warming is distorted. It's more in the Arctic than it is anywhere else. Now, it's interesting. Greg yesterday pointed out what's going on in Antarctica, that the melting of the Antarctic ice cap is below. And see, I said, well, bingo. Well, when I look at these temperatures off New Zealand, the sea surface temperatures off New Zealand, and what's going on in the North Pacific, I'm like, well, what the heck? Why aren't we trying to observe what's going on there instead of just we could see it in Antarctica because we got more saturation of data down there, and I don't know if it's a coincidence, is it? There's the increase in seismic activity, and it correlates nicely with the increase in sea surface temperatures. Again, if you increase the temperature of the ocean, you put more water vapor in the air. We know the relationship of water vapor to temperature. You know how you can figure out what CO2 is done? If you could, and this is what drives me crazy about my field. All you need to do is try your very, very, very best to approximate the water vapor transport into the air from, let's say, the sea surface temperatures in 1983 versus now, all right? Because there's no one, when you look at these temperatures, if you had the sea surface temperatures you had in the 70s and 80s, no way is it warming up the way it is. And so whatever minute warming there is, that may be your man-made warming or whatever they want to call it today. Now look at this. All right, this is the oceans in 1988, and the first big increase of seismic activity began in 85. But look at how cold the sea surface temperatures are in 1988. Look at the oceans now. You're not even looking at the same thing. As far as the transport of energy from the oceans into the atmosphere, this is remarkable. And by the way, apparently there's a CO2 ferry that I don't know about in the southern hemisphere and in the northern hemisphere that says, I bequeath a hot spot here and a hot spot there and a hot spot there. Look at the hot spots in there. Where the heck are they coming from? So the oceans they're warming up. And what happens is, you see the atmosphere, Le Chatelier's principle, you see the atmosphere fight back, try to even it out. But every time it cools, it leaves the base temperature of the ocean a little bit warmer. So we got to figure out what the heck is going on here, all right? Again, I don't have the answers. But if you tell me it's not CO2, right, we all agree on that. If you eliminate some of these other things, there must be something causing this to happen. So these hot spots are very important in the forecast. Now watch this. This is from Joe DeLeo at weatherbell.com, all right? He points out the hot spot in the North Pacific, and it argues for western and central cold in February and March. He said, well, it's been awfully warm in February. Oh, wait till March is done, right? It's like the revenge of winter is coming for much of the United States, including people in the Northeast. It's almost like the hurricane season, remember? At the end of August, oh, nothing's going on, blah, 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 blah. And look what happens, right? You can see the atmosphere setting things up. So each of these areas, what Joe does is, he looks at certain sea surface temperatures in certain areas, and he correlates the temperatures over the United States, right? The problem is that when we talk about this, when we make our seasonal forecast, I go, well, Joe, I don't think you could use 1978 with today, because there's a completely different now I'm not going to say completely different, but the feedback is a bit different today. So February, March come out like this, so you say, oh, wait a minute. It's been warm in the central part of the United States. Like I said before, you know, we've got a tremendous stratospheric warming event going on now, right? And the last two times that happened, beautifully correlated, 84 and 2018, the blend of those two will come out to that. So if the oceans had not warmed, the air would not have warmed significantly. The oceans and more water vapor in the atmosphere, so warming is more in colder, drier areas in the winter season. It distorts the warming, changes the feedback. Now, Willie soon got me thinking, because he and the Connollys have taken a lot of balloon measurements, and the Hadley cell is collapsing, which would make sense if you have distorted warming. Why? Because if there's more upward motion further north, what's that going to do to the Hadley cell? This is big in meteorology. It's also, by the way, not a sign that the planet's going to blow up. It's a sign that the natural fight back of the atmosphere to the warming that is occurring. That nature's fighting back. It has major implications. All right, more water, blah, blah, blah. I'm just going to go through this real quick. It influences everything. Hurricanes are developing further north, but they are smaller in size. We've got to get rid of the Saffir-Simpson scale. I've been proposing a power and impact scale that measures the radius also of gale force winds, 34, 50, and 64 knot winds. Not this, oh, well, right near the center, you've got 125 mile an hour winds as a category 4, right? I'm like, well, wait a minute. Harvey, which hit Texas, and of course it stalled and they had a lot of rain, but Harvey's radius of hurricane force winds was 150 miles. Carla's was 400 miles. How are they both category 4s? If Donna went through Florida today, if Donna from 1960 went through Florida category 4, you might have had $1 trillion of damage. That's how powerful Donna was. And Donna didn't screw around. She was still a 3 in North Carolina, a 2 up in New England. That's an unbelievable storm. So look at the Arctic. No warming in their warm season. Oh, isn't that interesting? It's only warming in the winter. Now, I wonder why that would happen. Well, part of the reason is that if the action of refreezing actually warms the atmosphere, melting actually cools it. But the amount of water vapor increase is not yet great enough to affect the temperature around 32 degrees. News flash to people claiming that the Arctic ice cap is missing. The average temperature around the Arctic is 32, 33 in the summertime. So if it's not getting much above freezing, guess what? That Arctic ice cap isn't disappearing. Now, you have to be ignorant, in my opinion, to spout what leftists do on climate migrants. How the heck is a generation or even two generation going to measure 0.1 C increase in temperatures in Central America, right? You see there's virtually no increase here. However, if you are a polar bear that wants to migrate south, you do notice it is warming up in the Arctic more. Another thing, John Kerry, remember Boko Haram? That's a major drought, and that's why we have a terrorist organization. Well, the reason why we've been having bigger hurricane seasons is because it's wet in Africa. Bill Gray used to talk about this, and it's been very, very wet in the areas where Boko Haram, not a drought. They just say stuff, and no one calls them on it. I'm just absolutely fascinated with this. The Pacific Ring of Fire, every time the La Nina shows up, you can see the sea surface temperatures remaining very, very warm. In fact, that area around New Zealand, I wish they'd do some research on that, because the sea surface temperatures are unbelievably warm there. Now watch this. 1951 through 1960, these are the sea surface temperature anomalies, skin surface temperatures, right? We go 1981 to 1990. Not much change, would you agree? See any change? But the most recent 10 years, it is warm. Now, why does that just happen all of a sudden? And believe me, when you look at the change in the anomalies over the North Pacific, this is a big, big deal for forecasters. Now, until the early 90s, the TSI was in lockstep with temperatures, right? But then the temperatures began to shoot up. So there's no change, the sea surface temperatures, no change for 40 years, and then the jump. Here's TSI versus water vapor. I got this from doctors. You can't beat that correlation, can you? All right. I would say. Now, this is seismic activity, underwater geothermal forcing versus temperatures. That's pretty darn good. Now, this is I steal from Dr. Spencer here. My argument on this water vapor is that every time a Super Nino goes off, an amazing amount of water vapor goes up into the air. When it spreads out, where do you see the warming? It's in the Arctic more, right? All right, so if we continue on here, CO2 versus temperature, if we're playing the correlation game, it has the least amount. You see what I'm saying? So I'm sitting here going, well, why aren't you looking at the other things? Why isn't my community, these young guys, I go, why do you just sit there and go along with it? Aren't you curious as to why it's happening? So TSI and seismic activity, stronger correlations in CO2. What's the cause? Let me move through this, okay? We can see the proof in the weather. See where and when it's warmer. Changes in sea level pressure and global wind oscillation, tropical cyclone changes. Let me go through this quick. Again, no warming in the Arctic during its summer season. That's a big key. All right. Now look at this. You guys, I'm sorry I get so fired up about this. It's like, this is what God made me to do, so I go crazy over it. Look at the sea level pressures over Southeast Asia and across the United States and in the Arctic in the last 10 years. Now look at those surface pressures, 76 and 85. You had high pressure all over the place. Now do you understand what that means as far as the global wind oscillation? All right, if you have lower pressures over Asia, Southeast Asia, it's creating stronger easterlies through the tropical Pacific, which tends to lead to more subsidence, sinking air over the tropical Pacific. Hence, the reason why that Hadley cell observation may be what it is. change in the global wind oscillation, sinking air relative to the normal vertical velocities over the tropics, the drying over the tropics, counter to the trapping hotspot idea. Remember, listen, if you trap heat in the Arctic, it's not that big a deal, all right? If you trap heat over the tropics, you're in a heap of trouble, boy, because what's going to happen is that's going to start feeding back like crazy. That goes against nature also. The warmer it gets, the tougher it is to get it warmer. It's much easier to just cut the feed out from under this, and all of a sudden, the temperature drops a ½ degree C across the planet, and people are starving. Shifting the size of storms, shifting the hurricane paths, the weakening of the Hadley cell, more increased solar radiation over tropical waters, more outgoing long radiation, which CO2 does use. You know what? If the oceans had not warmed, CO2 is not even a big deal. I don't think it's a big deal anyway, but CO2 feeds on the warming of the Earth. It's not the CO2 warming the Earth, it's the Earth is getting warmer, so there's more outgoing long-wave radiation showing up. And you know, what Anthony showed, 1 minute. I haven't told my jokes yet. What Anthony showed, those nighttime pictures, right? I could tell you horror stories about the Penn State sighting place with that stuff. Now look, real quick, West Pacific storms, 1959. Notice the track race east of the Philippines, right? This is 59. Look at the most recent year. They're further north. They're developing later. Even the hyper season, this is 1933 versus the 2020 season. All of them are developing in closer to the coast, where the Irmas are becoming more and more rare. So I talked about replacing the Saffir-Simpson scale. Specific humidity, real quick, 1951 through 1960, this is 400 millibars. 1976 to 85, boom. Look what's going on. It's drying out. It's drying out and shifting west. There's no fingerprint as far as this trapping hotspot goes. There's 400, do you realize how opposite this is? There's 400 millibar cooling over the tropics, and the stratosphere is warming up over the tropics. What does that mean? If the stratosphere expands, what happens to the troposphere underneath? It's actually cooling a little bit. We're starting to see that. It's distorted. There's distortion of the warming in the north. That changes a bunch of things, and it's also the sign the atmosphere is fighting back. So I'm done. I went over this before. The Hadley cell is weakening, and there's a reason for you set me off over there. So it's not CO2. My questions are raised based on observations, need to know. The hypothesis is formed based on a search for the unmoved mover behind this. So guess what? Let's say there is more seismic activity going on. We find it's heating up. Then we look, well, what the heck is causing that? Now, I happen to believe the sun and the pull of the sun and the moon and that's where the sun is the grand conductor of the entire orchestra. But in the meantime, I'm still trying to figure out who the lead soloist is right now. And it's important. And some of you meteorologists out here that are still forecasting, you got to figure out where the heck this is coming from, because it's a big, big deal as far as the feedback's concerned. All right, enjoy the weather. It's the only weather you got.
All right.
They can, they'll be answering questions at the tables. They've each got speakers. Why don't you go ahead and pull yours over, Anthony? As I said, raise your hands. I will recognize you. She will deliver a microphone. Stand and identify yourself and ask one question. The gentleman right back there first. If you can, tell your question to a specific speaker.
Joe Bastardi. I'm Ken Haapala, SEP. And what do you mean by TSI?
Total solar irradiance, isn't that right?
Yes.
Thank you. He's the astrophysicist. Mongo just pawn in chess game of life. Blazing Saddles. No one knows that. Jeez. You too.
I'm Francis Menton, the Manhattan Contrarian. I think my question comes out of Dr. Soon's presentation, but it could be addressed to anybody. what you said with regard to the homogenization of the temperatures that somehow these algorithms that our government weather people, data people, put into the temperatures to cool the past and raise the present. I think you used the term, they have a problem that they don't recognize. My question is this a problem they don't recognize, or is this an absolutely intentional effort to enhance the warming trend? And is it done by, who does it? It's done by how many people do these algorithms? Is it a small number of people? What are their names? And can we find out what the hell is going on here?
Thank you, Francis. You have a very sharp question. I do have to be a little bit more polite than usual since my two kids are here and my daughter is watching at home. Obviously, I'm sorry. I'm also one of those is no PC. Sorry, no PC. No political correctness. Yeah, I think they do know some of these problems and they just won't do nothing about this. So that's why I think we may need to start what Anthony Watts is proposing, but the problem is that we want data for 100 years or 200, sorry. So kids, please, shape up. Time for you guys to take over. You know, we need more kids, more students who wants to learn anything meaningful in life and do this. Yeah, there are a lot of names, but of course, I write it in my books, a little black book, and then I'll share with you. And anybody who wants to know, obviously, but let's not name them publicly here. Tom Carr, are you there? Plenty more, plenty more.
Thank you, gentlemen, for your excellent presentations. Steve Welsenbach of Reality News. I guess, Joe, this is more towards you. The HARP system that was developed by the U.S. military with the purpose of doing weather modification. How much are you aware of that, and what impact do you think it might have as far as being one of the unknown causes?
I don't know much about it. I do know Fidel Castro accused the United States of stalling a hurricane over his island in 1963, Flora, as a payback for what happened with the the Bay of Pigs or whatever. The only thing that I am advocating for now, and people just don't even like, I think we should be seeding these intensifying hurricanes that are coming to the coast, because I believe you can actually mitigate the strength of the hurricane if you can disrupt eye wall processes. And so that kind of modification, I think, is pretty good. There's all sorts of crazy things I've heard going on, like the state of Washington or Idaho was suing Washington because Washington was seeding clouds and meant it wouldn't rain in Idaho. So I don't like to mess with nature. And there's something else going on. These people putting particulate matter into the stratosphere. I'm like, what kind of lunacy is that? Except, of course, now we could shoot down the balloons so we can get away with that there. But I'm not into modifying anything that God has created. All right? I guess that's my answer.
Well, thank you.
If you believe in God. So.
I have a daughter who thinks that we're controlling the weather from a station in Alaska somewhere. So.
It's the mothership over top of the earth.
I have a question for Anthony. Anthony, is there a website or something for your new global open temperature system that we can refer to, and people can go there and see how it works and get interested in the program and try to kick in some money and buy one and install it somewhere?
Anthony, he was
There's not just yet. It's a work in progress. This is exceptionally new. I mean, literally, things are changing on a daily basis with this yet. So in the next few weeks, we will have a website where this will all be documented, and you'll be able to get this stuff, and it'll be more organized. I've been focusing on the technology and making the technology accurate, because the most important thing about this new temperature network is that it be unassailable, because they are going to attack it mercilessly. They will say, oh, your weather data, your temperature data is no good. Well, we're going to back it up with hard science, peer-reviewed papers, the works.
Hi, I'm Bob Bauman from the Right Climate Stuff. This is for Joe. One of the interesting things out of your talk was the rising sea level temperatures due to the volcanic activity under the seas. A lot of it occurring in New Zealand and Indonesia. From what I understand, the El Nino and La Nina effect that affect our weather patterns originate by ocean temperatures in that region. Is there a correlation there?
Well, first of all, let me just say something. I am not married to this idea. Like I said before, I got questions, right? And I'm trying to figure out, the biggest thing I'm trying to figure out is why the heck the rest of the meteorological community is just sitting there watching the sea surface temperatures, because it's tough to change the oceans. You understand that? You know the old saying, the wheels of the gods grind slowly but fine. That's the oceans, all right? It's not like the air. You could drive around on a calm night and see how quick temperatures could change. So this is a question thing. I'm not married to this idea. But what I suspect is going on is that the base temperature of the oceans is warming up, which is increasing. If you put more water vapor in the air, you are increasing feedback potential, all right? That does not mean that the weather is getting worse. As a matter of fact, total energy in the atmosphere may be increasing, but what we call zonal potential energy, the difference from north to south or south to north, depending on which hemisphere you are, is actually decreasing, which argues for less severe weather. Only if everything gets together, it can really fire up pretty quickly. We know that, okay? So I think that, and we got an El Nino coming on. You can already see it. In fact, the heavy rains caused by the La Nina across Indonesia and north of Australia this year, very, very important to why the U.S. winter so far has been very warm in the east. We call it the Madden-Julian Oscillation. Has been stuck in phase 4 and 5, driving me out of my mind because I do like cold and snow. So what happens is that cooling water now, we've seen the Indian Ocean cool. It's cooled all the way into that area. Well, guess what? Southern Oscillation Index, bang, it's taken a huge hit. The dailies are down to like El Nino levels, -20, -25, and you're seeing the warming already start off South America. So there's this big thing that goes back and forth. But I will tell you this, the very action of this nature of warming actually favors more La Ninas than El Ninos. The problem is when they come back, they can be very, very strong, and then you're going to see the global temperature go up again. So we're in a pause now off the super El Nino. I think Willie wants to say.
Willie wants to
I want to add one small little data point to support what he's saying, but all I say is that, look, we need more data. But the most important signal that no one talks about is that we already know this about 5-10 years ago. If you look under Central Pacific, no coastal process, no nothing, there's no way you can get the sunlight into this region. It's about 2,000 meters down. You look at the Argo data around there. The Japanese group found that, guess what happened? It's changing in a seasonal way. That tells you something about the orbit, Sun-Earth orbit. It's not sun per se, right? It's the orbital motion of the Earth around the sun. So, intrinsic signal. In fact, if you look below, there is actually very active magmatic region. You know, that probably the pulsing of the thing is doing that. So we can see signal like that already, but of course we need to see it for the whole globe and different places. And all this hotspot, it's all known, it's been monitored in some way. Okay, cut it short because there are many more.
I do want to add that the hot spots are getting hotter. It's something. The deserts are getting drier. No, but they are. They're increasing, and every time the sea surface temperatures fight back, it's left a little bit warmer.
I'm Gene Sklazacek from the Free State of Florida. This question is for Anthony. You mentioned several times in your talk that 96% of the sites that you evaluated failed to meet the siting criteria. What percentage of all sites did you evaluate?
Well, we looked at all sites, so I'm not sure what your question's about.
Well, no,
You continue to say of the sites you evaluated, 96% failed. So there's some implication that you didn't evaluate other sites, and you could have only chosen those that were going to fail, is what someone might claim.
In the publication, we have both good sites and bad sites. So we looked at them all. And some of the, for example, agricultural experiment stations, one in northern Idaho I visited, was perfectly sited. Everything was great, but the majority of them were not.
Thank you.
We've got Samantha running here back and forth.
Walt Johnson, Exploration Geoconsultants. Would a lot of this climate hysteria go away if we only use the maximum temperatures and we don't have to average in the heat sinks?
I don't think it's going away because I don't really think it's a scientific argument anymore. I think it's a socio-political thing.
If it's not the warm temperature, it will be the acidic ocean, it will be the ball trees and all kinds of problems. These people will come up with something more, for sure. So please, I don't think so.
Bob Enlick from Las Cruces, New Mexico. This is for Anthony. Did you notice that NOAA has made the climate research network data much harder to find? And if so, why?
Didn't get that.
He asked, have you noticed that NOAA has made climate research data much harder to find? And what is your response to that?
Did NOAA what?
NOAA making research data harder to find.
Oh, well, I don't think that they're making research data harder to find. I just think that they don't give any credence to it because the public probably wouldn't understand it. The U.S. CRN data it's available publicly, but it's not well displayed. You have to know what you're looking for to go find it. So, and it's never mentioned in any of the reports. The thing that I think they are doing consciously is not bringing this data to the attention in their public reports. Their monthly and yearly climate reports are completely absent of this data. And so that's our goal here, to make this kind of data more visible. Because when someone says, for example, well, San Antonio hit a high of 105 today, if you look at the stations near that are on the periphery of that, they might hit 98. This is never mentioned. And so what we're trying to do is illustrate the fact that UHI and siting problems are creating artificially high temperatures and also inflating the trend.
I'm going to disagree just a little bit. Past data is disappearing. The wildfire data, they've just truncated it. You can't find the older data on their sites. If we hadn't saved it to certain sites, it'd be hard to find. They're doing that with several other things as well. So present data is not impossible to find, but if you look at the past data, where it's inconvenient, it seems to be disappearing.
Terry Ciccone, Sarasota, Florida. Question for Joe. Sometimes I get the opinion that the other side uses us and what we know against us to make their own cause. For example, why do we even indulge in all these trivial accuracies or lack of accuracies on CO2 levels? It doesn't cause climate change. End of discussion, move on. Same thing with the readings from the temperature stations. We know they're corrupt beyond recovery. We should just dismiss any discussions on the subject, throw the questions back in their face, and simply rely on more reliable satellite temperature. I think sometimes, we're our own worst enemy.
Well, let me just say, there are many times I've said, I wrote a couple of books, and I said, you know what, okay, I'm out of this, right? What bothers me is the lack of truth. I don't like people spraying me with a garden hose and telling me it's raining. I'm saying that as nicely as possible. You have to understand something. You're speaking as a rational, objective human being wanting the truth. That's not what this is about. This is about a greater truth. In my opinion, I came to this conclusion about 2015. This is not about climate, not about science. We love fighting these little tit-for-tat battles. It doesn't make a difference, all right? So it's actually freed me up to just say whatever I want to say a little bit more because I don't worry about repercussions. But what it is there is an agenda out there that somehow or the other, that the United States of America and our system is bringing down the rest of the world, when in reality, you know, Barack Obama famously said, 4% of the people, 25% of the resources, right? Yeah, but look what we've done with them for the rest of the world, that the rest of the world is advanced because of our system. And there are people, they hate what's going on in the United States, and I believe they brainwashed a lot of people into looking at it that way. Okay, you can't talk to them, see? But I think you're exactly right. I mean, what are you supposed to do, though? Lay over? I don't even know what TikTok is. My daughter sets up my stuff.
Hi, this is Greg Goodnight, the Right Climate Stuff. This is for Anthony. I continue to be amazed how the 1930s continues to cool even today. Whenever NOAA comes out with their things, my question to you is this time of day adjustment. I understand there was presumed error in the time of day measurements, you know, the two measurements. Could you comment on the 1930s and why in the world does it continue to cool?
Well, can you restate your question, because it doesn't quite make a lot of sense to me.
If you look at NOAA, the 2019 temperature records, what you see is the 30s, and the period that it was very hot, it came down in terms of temperature. And I was told it was a time of day adjustment where they presumed that the temperatures weren't taken properly during that period, and that was the rationale for the adjustment. So are you familiar with this?
Yeah, I've seen the cooling effect associated with homogenization. It tends this happens, it seems, everywhere. And it's a statistical fluke. The problem is that they're trying to create a temperature that represents a surface. And so they do this by combining these stations with the homogenization process, so they can say the temperature average of the United States was X. The problem is that the homogenization process itself corrupts the data, and the artifact is that it tends to cool the past. And they think that this is perfectly fine because in their minds, well, those temperatures must have been overestimated anyway. It's a confirmation bias type thing going on.
You ever wonder, real quick, how a Category 4 hurricane for 50 years suddenly got downgraded to a Category 3, Audrey? How the heck did that happen? The people, Audrey was the strongest June hurricane on record, hit 947 millibars, 140 mile-an-hour winds, southeast Texas Gulf Coast, Beaumont, Port Arthur. All of a sudden, well, wait a minute, that wasn't, it's down to a Category 3, and I suspect, I hate to say it, I suspect the reason is if some other strong June storm shows up, which is going to happen someday, they can say, see, Audrey wasn't the strongest. How does that get downgraded? By reanalysis. Where the heck did this stuff come from? So I believe in science and reanalysis, but man, stuff like that, oh, Audrey's no longer a 4, it's a 3. How come it's always downgraded? By the way, you older folks in here, I know the weather was, you think it was bad when you were younger, but no, it wasn't.
Michael Justino, Cleveland, Ohio. For Anthony, you mentioned earlier about the 96% of the global temperature, United States global temperature. Okay, good. My question is, have you or anybody else looked at the rest of the stations throughout the world to correlate a percentage of the standard not being met?
Well, despite the fact that everyone thinks that I'm funded by ExxonMobil, I don't have that kind of travel budget. But I can tell you that we have done some spot checks of stations around the world and found similar problems. The biggest problem associated with finding these other stations around the world is that they're not well documented. NOAA, to its credit, has put together a fantastic database about where the stations are and their history. It's called the HOMR database, and it's a fantastic database. But there's nothing like that for the UK even, for example, or for South Africa or any place else. So a lot of the locations of these stations are a mystery in the sense of we can't go to a database and find an exact latitude and longitude as to where these are. There is a latitude and a longitude published for these things, but they're very coarse. And so, we have to look over, several square miles to try to find a little dot on Google Earth, and it's nearly impossible. But based on what we've seen, yes, the problem exists elsewhere.
This will be the last question.
Ian Plimer from Adelaide, Australia. A question to Joe. Why do you think the geophysical and geological data on heat flow has been totally ignored? We have more than 150 geothermal sites underneath the Antarctic ice, a large number under the Greenland ice. We have 3.5 million submarine volcanoes which cool from 1200 degrees Celsius to 2 degrees Celsius, the temperature of bottom water. Why has that been absolutely and totally ignored?
What? Do you want the cynical Joe Bastardi, the skeptical Joe Bastardi, or the, oh, let's all get along Joe Bastardi? I don't think they want to find out what the heck is really going on. I don't understand it anymore. I used to always, I always assumed the best. In fact, Dr. J. Lair, the late Dr. J. Lair, who I absolutely loved, he said, my problem is I'm too nice. That's what he always said, because I always assume the best about the other person. But your question brings up my question. Why the heck aren't we looking at that? At least look at it, and then you can dismiss it if you come up with conclusive proof. So the cynical me says they don't want to look at it. And now I'm the conspiracy guy from Letterman from years ago, right? So, but I don't think they want to look at it. Why not? What could it hurt? Except it'll blow the whole ESG idea apart if it's not CO2, right? By the way, I didn't know what ESG was. I thought they were a new rap band, and then...
Might as well.
Yeah, it's, it destroys the narrative. Let's take some time to thank our speakers for being up here. Thank you for being here yourselves. This is panel 2A. I'm pinch hitting for a moment. We'll see if it winds up longer. It's understanding what's really happening to climate. If that's not the panel you wanted to hear, if you wanted to hear about the ESG, then you're in the wrong room. But if you're here, I'm going to assume that this is what you want to hear. I don't have the introductory materials for this, but we have a great panel. Perhaps the most accomplished panel of any of the, of many accomplished panels. We've got some really stellar people here. I'm happy to introduce Dr. Judith Curry will be joining us live remote. Ross McKitrick, Dr. Ross McKitrick, he's on stage here, and Dr. Richard Lindzen, who I've long been an admirer of. And I'm not going to belabor it because I didn't prepare introductory materials. I'm going to let them go. I think we're going to let Dr. Lindzen go first. Oh, well, now, let me ask. I see Ross McKitrick's thing up. Should he go first? Okay, Dr. McKitrick will go first. My apologies.
And just as I begin, can I get someone at the back to close the doors, and then that'll keep the hallway noise down. Thank you. So I'm speaking about the social cost of carbon, and some work that Kevin Diaratna and I have just published in a journal on this. Now, the backstory is we published a paper with the late Pat Michaels back in 2020 in a journal called Environmental Economics and Policy Studies. And what we did there was we took one of the models that was used by the EPA to calculate the social cost of carbon, and we updated it to reflect more recent evidence in the literature on some of the key parameters, and showed that it made quite a big difference in the estimate. And I'm going to explain what the social cost of carbon is, or at least what it's purported to be. There's a large literature here that's aimed at generating estimates of the social cost of carbon, and we made a contribution to it. And then more recently, someone published a critique of our work. And so the new publication that Kevin and I did that just came out is a response to that critique. All right, so social cost of carbon. Love it or hate it, this number plays a big role in a lot of regulatory decisions. It's basically why we can't have nice things anymore. The social cost of carbon calculations are very dependent about a handful of assumptions in the key models that are being used. Now, if the number comes out near zero, that implies that releasing a ton of CO2 emissions doesn't really have any negative economic consequences. And if that's the case, you can't justify costly abatement policies. So for a long time, the economics literature has been putting out a lot of results that says the social cost of carbon is pretty close to zero, may even be negative. And so on a cost-benefit basis, most of the climate policies that get discussed fail the test. As a result, governments around the world are conspicuously trying to find reasons to boost the social cost of carbon estimates. And so there's a few key things that they can do, like introducing tipping points into the model, or mortality functions, or agricultural damages, or anything. And there's a kind of a contest in the literature who can publish a tweak that generates large social cost of carbon numbers, because regulators will love it, and your work will get praised and highlighted. The work goes on in what are called integrated assessment models. So these are combined climate and economy models. They were first developed by William Nordhaus at Yale University, who eventually got a Nobel Prize in economics for this work. And the model runs an economy and a climate together over time and solves for the optimal social cost of carbon, optimal based on all the assumptions about the sensitivity of the climate to greenhouse gases, the damages from warming, and the costs of reducing greenhouse gas emissions. And it's especially that last part that matters. The cost of reducing greenhouse gas emissions is very high. And as a result, integrated assessment models have traditionally shown that most of our mitigation policies aren't worth doing. Nordhaus's work himself has shown that for the most part, you just have to live with it. That you can't really justify expensive emission abatement policies. And the way that's expressed in economic parlance is the optimal price of carbon is too low to justify aggressive emission cuts, certainly too low to justify net zero targets. Now, key parameters. First one is equilibrium climate sensitivity. And this is a parameter in the model that says how much warming would you get if the amount of CO2 doubles in the atmosphere. And obviously, if you have more warming, then that has bigger effects on the economy in the model. The discount rate is the parameter that says how much you should downweight costs and benefits that happen in the future compared to those that happen in the present. And then the CO2 sensitivity refers to how much agriculture productivity is boosted by having additional CO2 in the air. Now, the equilibrium climate sensitivity in these models, as used by the EPA, is based on something called the Rowe-Baker distribution. So the Rowe-Baker distribution, this was from a study published in 2007 that looked at the behavior of a whole bunch of climate models, and they drew that green line that you see there, a distribution of possible climate sensitivity estimates, and it ranges from a low of 1.5 degrees up to about 7.5 degrees at the upper end, and it has a median of 3 degrees. So when the EPA runs these integrated assessment models, they run it thousands and thousands of times and draw samples from the Rowe-Baker distribution, and then they get a distribution of social cost of carbon estimates. And they did that with 3 major integrated assessment models that go by the names of DICE, FUND, and PAGE. Now, as far as the discount rate, the Office of Management and Budget recommends for public projects a 7% discount rate. In the climate literature, a lot of economists say, well, if we're talking about such long time horizons, we should use a lower discount rate. So typically in climate economic studies, people vary the rate from 2.5% to 7% just to see what the effect is. And then the CO2 fertilization, there's one model, the FUND model, that includes benefits to agriculture from all the extra CO2 in the air. The 2 others just ignore the effect altogether. So they don't have a CO2 fertilization effect at all. Now, what we did Pat and Kevin and I, we took the fund model and we made a couple of changes to it. So first of all, we took out the row-Baker distribution and we used a new empirically based climate sensitivity distribution due to Nick Lewis and Judy Curry, and that distribution had a mean or a median sensitivity of 1.6 degrees and a range of 1.2 to 2.2. And this was based on, not on running climate models over and over, but based on observations over the 19th and 20th century, applied in an estimation model. And then there's another estimate John Christie and Dick McKnider did using lower troposphere data, which came up with a median estimate of 1.4 degrees and a range of 1.1 to 1.8. Obviously much lower than the row-Baker distribution, and consequently they generate lower social cost of carbons. As far as the CO2 fertilization effect, the fund model was set up based on information available in the early 1990s. Since then, there's been a ton of work on global greening and also the plant benefits, agricultural benefits of CO2. And so we used a meta-analysis published by Challenor et al., which showed that the CO2 fertilization effects are much larger than what had been anticipated 20 years earlier. So we tested for 15 and 30% increases in the fund model agricultural productivity parameters. And then we used a variety of discount rates. So the results of that paper, if we stick with the row-Baker ECS estimate, but we increase the CO2 fertilization by 15%, that didn't have a big effect. The social cost of carbon falls by about 4%. But if we go up to a 30% increase, the social cost of carbon falls by about 25%. The bigger effect, though, is updating the ECS distribution using either Lewis and Curry or Christie McKnider. That causes the social cost of carbon estimates basically to fall to zero out through 2050. Even without increasing the CO2 fertilization effect, the social cost of carbon falls from the mid-30s down to under $5 using a 2.5% discount rate, and falls to minus 77 cents using a 5% discount rate. So the results look basically like that. The upper line is the result the EPA calculated using the row-Baker distribution. The three lower lines are what we got using either no increase in CO2 fertilization or 15 or 30% increase. And those are the estimated social cost of carbon rates from 2020 out to 2050. Any one of those three lines would mean you can't justify any climate policy on cost-benefit grounds. Okay, so then a comment was published last year by Philip Meyer. We don't really know anything about him except he's a US government employee somewhere. He pointed out that the Lewis and Curry 2018 paper has been superseded by a new study by Nick Lewis, which was published last year, which has a median ECS of 2.2 degrees. He also argued that the Christie and McKnider estimate isn't really relevant because people live on the surface, not in the troposphere. He argued that Challenor meta-analysis has been superseded by an analysis by Moore et al., which has a very large data set, and they found much smaller CO2 benefits and net losses from warming. And then going over the discount rate issue, he said the DICE model has a close to a 5% discount rate, so that would be an appropriate one to use. He didn't recalculate the social cost of carbon estimates, so we go through all his comments and then do it for him. And so our responses to that, first is, yes, the new paper by Lewis is a good analysis. What Lewis did was, in the most recent IPCC report, they've stopped using climate models to generate their distribution of ECS estimates. Instead, they latched onto a study by Sherwood et al., which combined paleoclimate and modern instrumental data and came up with an empirical estimate. And what Lewis did was he showed that, okay, that's a valid method, but they were using older versions of the data sets. And if you update the data sets, and even the IPCC has updated the data sets, the median distribution falls to 2.2, which is well below the IPCC's estimate of 3.1. But also, if you confine it just to the instrumental data set, their method gives you 1.8 C, which is pretty close to what he and Judy Curry had estimated before. On the second point, we point out that the troposphere data is actually ideal for the purpose. Yes, people live in cities on the surface, but that contaminates the surface temperature data, as the last panel discussed. So the tropospheric data, if you want to isolate the effect of CO2 on warming, that would actually be an ideal data set to use. The Moore et al. Study just reused the Challenor data set. It wasn't a new data set at all. What they did was they changed the estimation method, but they didn't provide any details about their modeling assumptions, but you can tell that they use different functions that just suppress the CO2 effects and the benefits of adaptation. And so we don't find that a credible advance on the earlier work. And then finally, okay, 5%, we'll go with that. So the new result, if we use, first of all, if we used a 2.5% discount rate and the new 2.2 degree ECS, and we don't change the agricultural fertilization effect, then the new result's about midway between what we published a couple of years ago and the old Roe-Baker analysis. So the Roe-Baker result would be the top red arrow. The result we published a couple of years ago is the bottom red arrow. The new result, based on the Lewis distribution, would be the red arrow in the middle. But there's still a 15% chance the social cost of carbon would be less than zero as of 2050. If we use the 5% discount rate, the numbers there are probably too small for you to read, but under any assumption, using the 5% discount rate, but whatever CO2 fertilization effect we put in, using the Lewis 22 ECS estimate, the social cost of carbon is $3.39 as of 2050, and that's the highest it gets. So putting all these things together, if we look at the social cost of carbon at 2050 using a 5% discount rate, under the Roe-Baker distribution, it's over $5, but using the new Lewis 22 distribution, it's $3.39, 33% probability that it's below zero, meaning CO2 is a net benefit. Whichever one of these we choose, and the Christie-McNider estimate there is minus 72 cents. Either way, and again, these are the models the EPA themselves used, you can't justify any climate policies on cost-benefit grounds using these kinds of numbers. I'm almost done, actually. So the conclusions that we reach, in our 2020 paper, we showed that updated empirical evidence yields social cost of carbon near zero, at least through 2050. We don't agree with all of Meyer's recommendations, but if we take them at face value, the result is that the social cost of carbon remains very close to zero or below zero for many decades, and the resulting social cost of carbon number is well below any level that would justify current mitigation policies. Now, none of this is to say that we agree with those models or with the parameter choices or things like that. The point here is to say, okay, this is how you guys constructed the case for your regulations, but you haven't used very good data in your models. So if we improve the data in your own models say that you can't justify the policies. Working in a field like social cost of carbon calculations, it's always a moving target. So more recently what's happened is the EPA seems to be gravitating towards a study that was put out by Resources for the Future, which now gets rid of all the integrated assessment models and has brought in a couple of brand new ones that no one's seen before. And they have much, much higher social cost of carbon estimates. So it's now going to be back to the drawing board to take those apart and figure out why it is that even though they've also conceded that the emission projections are way too high. So they've cut their emission projections quite a bit. But they're still getting, well, now the social cost of carbon estimates is about $170 a ton. So there's some magic sauce in there somewhere. And like I say, they've they're not even using the models that they used a couple of years ago, the 3 integrated assessment models, including the one that got a Nobel Prize. Now those are out the window, and they have brand new ones that we haven't seen before. So it's a moving target, like I say, but those are the last few findings that we've got into the literature. Thank you.
We've got Dr. Curry's online talk already queued up, so we're going to go with her next, and then Dr. Lindzen will be the closing act, the old headliner,
Hello,
as they used to
everyone.
say with concerts when I would manage concerts.
Even people that don't know much about climate science have heard that 97% of climate scientists agree. But exactly what do they agree on? Not nearly as much as is portrayed in the media. Everyone agrees that surface temperatures have increased since 1880, humans are adding carbon dioxide to the atmosphere, and carbon dioxide and other greenhouse gases have a warming effect on the planet. However, there is much disagreement on the most consequential issues. How much of the recent warming has been caused by humans? How much the planet will warm in the 21st century? Whether warming is dangerous? And how we should respond to the warming to improve human well-being. The first 2 points are in the realm of science, requiring logical arguments, model simulations, and expert judgment to assess whether and how much. The issue of dangerous is an issue of societal values about which science has little to say. Whether reducing CO2 emissions will improve human well-being is an issue of economics and technology. This is also contingent on the relative importance of natural climate variability versus human-caused global warming for the 21st century. Nevertheless, we are endlessly fed the trope that 97% of climate scientists agree that warming is dangerous and that science demands urgent reductions in CO2 emissions. So why do scientists disagree? The most fundamental source of disagreement regarding the theory of human-caused climate change is natural climate variability. Why do climate scientists disagree on the relative importance of natural versus human-caused climate change? Well, the historical data is sparse and inadequate, particularly in the oceans. There's disagreement about the value of different classes of evidence, notably the value of global climate model simulations and paleoclimate reconstructions. There's also disagreement about the appropriate logical framework for linking and assessing the evidence. And finally, there's little acknowledgement that some climate processes are poorly understood or even unknown. Science works just fine when there's more than one hypothesis to explain something. In fact, disagreement spurs scientific progress through creative tension and efforts to resolve the disagreement. In the 1990s, the IPCC made a fateful decision to formulate their reports around consensus. The IPCC arguably adopted a speaking consensus to power approach that sees uncertainty and dissent as problematic and attempts to mediate these into a consensus. The speaking consensus to power strategy acknowledges that available knowledge is inconclusive and uses consensus as a proxy for truth. The consensus to power strategy reflects a specific vision of how politics deals with scientific uncertainties. The IPCC's manufacture of consensus has done incalculable harm to climate science and the policymaking that is informed by climate science. An explicit consensus-building process has enforced overconfidence and belief polarization. Consensus beliefs are serving as agents in their own confirmation. Dismissal of skepticism has been detrimental to scientific progress. Over-reliance on expert judgment has motivated shortcuts in reasoning and hidden biases. And finally, narrow framing of the climate change problem has provided a basis for neglecting research in certain areas. So how did we come to the point when we're alleged to have a future crisis on our hands, but the primary solution of rapid global emissions reductions is deemed to be impossible? The source of this conundrum is that we have mischaracterized climate change as a tame problem with a simple solution. The climate change problem is framed as being caused by excessive carbon dioxide in the atmosphere, which can be solved by eliminating fossil fuel emissions. Both the problem and solution are included in a single frame. This framing dominates the UN negotiations on climate change. The framing on the right addresses climate change as a complex, wicked problem. This framing shows two separate frames, one associated with the causes of climate change and the other associated with solutions that can help reduce vulnerability to climate change. The larger frame on the right also includes natural causes for climate change, such as the sun, volcanoes, and slow circulations in the ocean. This framing is provisional, acknowledging that our understanding is incomplete and that there may be unknown processes influencing climate change. The frame on the left is about controlling the climate, whereas the frame on the right is about understanding the climate. Further, the framing on the right acknowledges the futility of control. Solutions on the right focus on managing the basic human necessities of energy, water, and food. Economic development supports these necessities while reducing our vulnerability to weather and climate extremes. My own understanding of climate change and human well-being is squarely in the framing on the right. The climate crisis isn't what it used to be. Circa 2013, with publication of the IPCC Fifth Assessment Report, the extreme emissions scenario, RCP 8.5, was regarded as the business as usual emissions scenario, with expected warming of 4 to 5 degrees centigrade by 2100. Now there is growing acceptance that RCP 8.5 is implausible, and RCP 4.5 is arguably the current business as usual emissions scenario. And this is according to recent reports issued by the COP 26 and 27. Only a few years ago, an emissions trajectory that followed RCP 4.5 with 2 to 3 degrees centigrade warming was regarded as climate policy success. As limiting warming to 2 degrees seems to be in reach, the goalposts were moved in 2018 to reduce the warming target to 1.5 degrees centigrade. Climate catastrophe rhetoric now seems linked to extreme weather events. For nearly all of these events, it's difficult to identify any role for human-caused climate change in increasing either their intensity or frequency. The mainstream media is currently awash with articles from prominent journalists on how the global warming threat is less than we thought. The rationale for continuing to increase the alarm is that the impacts are worse than we thought, specifically with regards to extreme weather. Attributing extreme weather and climate events to global warming is now the primary motivation for the rapid transition away from fossil fuels. This rationale commits the logical fallacy of conflation. There are two separate risk categories for climate change. The first is impacts of the slow creep of global warming on sea level rise, contribution to regional water shortages, and hypothesized tipping points. The second is extreme weather events and interannual climate variability, which has little, if anything, to do with global warming. The proposed management strategy for both risk categories is to eliminate CO2 emissions. This strategy may have some incremental benefits in the 22nd century, but will not help with the emergency risks associated with extreme weather events. The appropriate way to deal with the emergency risk is fundamentally regional through economic development and vulnerability reduction. The urgency of addressing emergency risk is being used to motivate the urgency of reducing the incremental risk from emissions. Ironically, attempts to reduce emissions are exacerbating energy poverty and unreliability, which is increasing the emergency risks. One would logically think that if warming is less than we thought, but impacts are worse, that the priorities would shift from CO2 mitigation towards development and adaptation. However, that hasn't been the case. How did we come to the point where the world's leaders and much of the global population think that we urgently need to reduce fossil fuel emissions in order to prevent bad weather? Not only have we misperceived the climate risk, but politicians and the media have played on our psychological fears of certain type of risk to amp up the alarm. Psychologist Paul Slovic describes a suite of psychological characteristics that make risks feel more or less frightening relative to the actual facts. In each of the risk pairs on the left half of the slide, the second risk factor in bold is perceived to make the risk worse than it actually is. For example, risks that are common, self-controlled, and voluntary, such as driving, generate the least public apprehension. On the other hand, risks that are rare and imposed and lack potential upside, like terrorism, invoke the most dread. Activist communicators emphasize the man-made aspects of climate change, the unfair burden of risks on undeveloped countries and poor people, and the more immediate risk of severe weather events. The recent occurrence of infrequent events, such as hurricane or flood, produces elevated perceptions of the risk of low probability events. This then translates into perceptions of overall climate change risk. The cultural theory of risk proposes that our views on risk are filtered through cultural worldviews about how society should operate. Our perceptions of climate risk have been cleverly manipulated by propagandists. Even if the initial harm from climate change is small, the social risk is being greatly amplified by the collective responses and irrational behaviors of individuals. The response to climate risk, driven by alarmism and extinction rhetoric, has arguably crossed the threshold to actually increasing the social risk associated with climate change, including increasing risk from energy poverty and unreliability. Leading risk scientists and philosophers who don't have a particular dog in the climate fight have expressed their concern about how all this has evolved and where it is headed. Norwegian risk scientist Terje Aven has this to say: "The current thinking and approaches have been shown to lack scientific rigor, the consequence being that climate change risk and uncertainties are poorly presented. The climate change field needs to strengthen its risk science basis to improve the current situation." Philosopher Thomas Wells has this to say: "The global climate change debate has gone badly wrong. Many mainstream environmentalists are arguing for the wrong actions and for the wrong reasons, and so long as they continue to do so, they put all our futures in jeopardy." One of the reasons that the global climate change has gone badly wrong is that we have created problems at the interface between climate science and policymaking. Encroachment of politics into socially relevant science is unavoidable. Problems arise from many sources, and scientists, policymakers, and the media are all culpable. Policymakers misuse science by using science as a vehicle to avoid hot potato policy issues, by expecting black and white answers to complex problems, demanding scientific arguments for desired policies, and funding a narrow range of projects that supports preferred policies. Scientists misuse policy-relevant science by playing power politics with their expertise, conflating evidence with expert judgment, ignoring data and research paths that undermine their political preferences, entangling disputed facts with values, and intimidating scientists whose research interferes with their political agendas. Climate science is far from the only area of science that has been politicized. Others include COVID-19, gender studies, and genetically modified food. Cancel culture is alive and well in the sciences, where scientists that disagree with an interpretation that supports desired policy objectives are ostracized, with some even losing their jobs. The wickedness of the climate problem is related to the duality of science and politics in the face of an exceedingly complex problem. There are two common but inappropriate ways of mixing science and politics. The first is scientizing policy, which deals with intractable political conflict by transforming the political issues into scientific ones. The problem with this is that science is not designed to answer questions about how the world ought to be, which is the domain of politics. The second is politicization of science, whereby scientific research is influenced or manipulated in support of a political agenda. We have seen both of these inappropriate ways of mixing science and politics in dealing with climate change and also the pandemic. There's a third way, which is known as wicked science. Wicked science is tailored to the dual scientific and political natures of wicked societal problems. Wicked science uses approaches from complexity science and systems thinking in a context that engages with decision makers and other stakeholders. Wicked science requires a transdisciplinary approach that treats uncertainty as of paramount importance. Effective use of wicked science requires that policymakers acknowledge that control is limited and that the future is unknown. Effective politics provides room for dissent and for disagreement about policy options and includes a broad range of stakeholders. I have a new book that is in press entitled Climate Uncertainty and Risk. The subtitle for the book is Rethinking the Climate Change Problem, the Risks We Are Facing, and How We Can Respond. This book encompasses my own philosophy for navigating the wicked problem of climate change. As such, this book provides a single slice through the wicked terrain. By acknowledging uncertainties in the context of better risk management and decision-making frameworks, in combination with techno-optimism, there's a broad path forward for humanity to thrive in the 21st century. In many ways, this IPCC meeting is wicked science in action, with scientists, policymakers, journalists, business leaders, think tanks, and advocacy groups all in the same room. A broad range of perspectives is being presented and discussed at this meeting. Our challenge is to effectively harness all this in context of complexity science and systems thinking. The next time someone calls you a denier, you can respond with this: "Give me a break. I'm a wicked scientist." Thank you.
Dr. Richard Lindzen's next.
Well, let's see if I can see my slides. Yeah. Okay. The title is a little bit excessive, but it describes what I'm going to talk about, which is what I think climate is really doing, why I fear it doesn't matter with respect to policy, and why I think that matters might still turn around. Does this work? Yeah. Okay, here is a graph. Many of you may not have seen it. It's a simple graph John Christie and I put together. The vertical axis is temperature, degrees centigrade, and the horizontal axis is just various kinds of climate change that people know how to handle. Of course, these vary from place to place, and we've taken it from various cities in the U.S., all over the U.S., Seattle, Boston, so on. And at the far left, what you have, if I don't know, no, I can't use a pointer. At any rate, is the warming we've seen over the past 120 years. And that's barely budging off the bottom. And then we go to things like, from 8 a.m. to 10 a.m., and from sunrise to afternoon, and so on. And of course, it's increasing to very large amounts. And we deal with all of those. So a question arises, and the question is the following. How is it that the small seeming change in global mean temperature anomaly is taken to imply major climate change? And people don't deal with it. I notice even at this meeting, we bloviate about 2 degrees or 1.1 degrees and so on, and never deal with the fact we're dealing with something tiny. That shouldn't be a problem. Well, let's consider. The answer, especially with Sherwood's use of paleoclimate, is something called polar amplification. The idea here is that the mean temperature change, for instance, during the Ice Age or during the Eocene, was around 5 degrees. And, if 5 degrees in the change in the mean can be such remarkable change as a major ice age or the so-called climate optimum of the Eocene, then we better worry about small changes in sensitivity if they start approaching that. But where did this notion of polar amplification come from? And again, nobody is dealing with that here, but it turns out to be a crucial idea. It comes from paleo data, and that's what I've just mentioned. In paleo data, the change in the tropics to pole temperature difference, I'm referring to it here by little delta T2, is listed here. So you have these changes in the tropics to pole, 20 degrees in the Eocene, 40 degrees today, 60 degrees roughly during the glacial maximum. And they were accompanied by small changes in tropical temperature. Now, that has its own interesting history, and I won't dwell on it too much. The original studies of these phenomena, for instance, for the glacial maximum, actually had tropical temperatures increasing. And the original study by Shackleton in Burmsa for the Eocene had tropical temperatures decreasing. And that didn't look at all like what the climate alarmists were saying. So there's huge efforts to change it. And currently, the feeling for the Eocene by someone called Dan Schrager at Harvard is that it's the same as today. Nothing occurred. And for the glacial maximum, they've managed to squeeze out the possibility that it was also a degree cooler in the tropics. Okay, you talk about fudging data, it gets easier as you go back further, but all I'm saying is it's always small compared to this. So the idea was, this could mean that small changes cause it, but the question is, was this really polar amplification of the small and uncertain tropical temperature change? And let's look at it. Well, this is a kind of schematic of the temperature of the Earth. The horizontal axis is sine of latitude, so it gives an area averaging. The boundary between the tropics and the extratropics at x1 corresponds roughly to x1 equals a half, which is 30 degrees latitude. And you can go to the reference there if you want to derive it. It's trivial. But the average temperature here will be T1 minus this delta T2 fraction 1 minus x1 over 2. So that'll be roughly 1/4. Okay, so there you have a simple formula. And if you apply it to major climate change, what you find is, for the delta T2 component, you get about plus or minus 5 degrees, because it's 20 degrees change in delta T2, and you get almost nothing for delta T1. What that means is, obviously, that delta T bar is dominated by the second term, the change in tropics to pole temperature difference. Fair enough. But there's another question. Do we see anything like this in the current warming episode? And the answer is no. Here is the change in the tropics to pole temperature difference over the period 1880 to 2020. And it's, it gets smaller, it gets larger, it wobbles all over the place. It has almost no bearing to the mean. Moreover, the numbers, and I can barely see the index, but if you divide them by 4, they're pretty tiny. And you can see that now by comparing the mean temperature and the tropics, the global temperature. Orange is the global. And basically, the global tracks the tropics and is generally smaller and irregular. So we're dealing with two different climate changes. We're calculating our climate sensitivity based on the present, which seems to have nothing to do with major climate change. This is profoundly different. What's going on? Well, what's going on, in fact, is physics. The tropics and the extratropics represent profoundly different dynamical regimes. People here in Florida, I think, probably realize the tropics are very different from the extratropics. The prevailing winds are easterly in the tropics. In the extratropics, they're westerly. The major perturbations in the extratropics are the highs and lows that we associate with weather. We don't see the same type of thing in the tropics. They're smaller. There is a large Hadley circulation in the tropics. It ends at the subtropical jet, which forms the boundary to the extratropics. At any rate, so what's determining this? Why are the two profound regimes there? And it is because of the rotation of the Earth. I hope most of you are familiar with the term Coriolis force. Coriolis force effectively depends on the vertical component, the component perpendicular to the surface of the rotation vector of the Earth. So that's on the right there. And in the extratropics, the component perpendicular is significant, and in the tropics, it's almost parallel to the surface and does not inhibit cross isobar flow. What does that mean? Well, we'll see that in the next slide. The pictures again. The cross isobar flow in the tropics homogenizes horizontal temperature differences. And that, you'll see, is a characteristic of the tropics. The temperature differences with latitude are minimal. tends to be pretty homogeneous. On the other hand, where you have a Coriolis force in the extratropics, it inhibits wiping out the gradients, and we have the gradients. On the other hand, it has limits. It is due to an instability, and if you go beyond a certain point, the instability stops. And what did I just do here? I pushed the wrong button. Yeah. Okay. At any rate, so you have the cross-isobar flow homogenizing the tropics. In the extratropics, you have what is called baroclinic instability, the highs and lows. And their limit, it turns out, it's a really hard calculation. It was done by colleagues Malta and Ferrari at MIT. What it determines is the slope of one of these bars. What these bars are isentropic surfaces. For those of you who know meteorology, those are surfaces in potential temperature. And baroclinic instability says that the isentrope along which transport occurs that leaves the surface at the boundary of the tropics, that isentrope has a slope, and that slope determines the polar tropopause. Okay, that's technical, but it determines the temperature difference between the tropics and the pole at the polar tropopause level, about 6 kilometers. And it sets it to about 20 degrees. That's an interesting number. That is the temperature difference during the Eocene, when we had no ice and so on. You'll notice some of these bars originate not in the tropics, but at the surface. And they have an important role as well. The ones originating at the surface allow the influence of extratropical surface conditions, including the role of ice, which produces what's called the Arctic inversion, and the influence of ocean transport. But the crucial thing is the processes that determine the temperature difference are extratropical. On the other hand, the temperatures that determine the tropics do depend on the greenhouse. And the fluxes in and out. But turning back to this, it's telling you you do not have polar amplification. On the contrary, whatever is happening in the tropics is just an additive constant to the temperature everywhere. And so if you have 1 degree, 1.5 degrees, it doesn't give you a big thing in the Arctic, it gives you 1.5 degrees. And we've been sort of screwing around and ignoring the general circulation. Without polar amplification, small warming remains small warming. And for major climate change, like the Eocene or the Ice Ages, greenhouse-based climate sensitivity is largely irrelevant. Okay. In point of fact, although this is a major problem, it's completely ignored. But, part of the reason it's ignored is virtually every aspect of warming alarm narrative is faulty. Despite this, I think it is fair to say we are losing the battle in the policy arena. I differ with Greg on this, and I'd like to ask, why are we losing this battle? And the answers are pretty obvious. The alarmists control the funding which allows them to entrain many scientists and scientific organizations, including the American Medical Association. I mean, this is crazy. For anything we show, there will always be some so-called scientist who will claim the opposite. They've been paid to. They take advantage of the insecurity of the public to denigrate skeptic claims because they point out if the skeptics are wrong, then the public is at severe risk. They personally have more at stake financially. And they've learned from Goebbels that a big enough lie, repeated endlessly, becomes truth. And they are more sophisticated in preserving the narrative. And let me explain that. It took me a long time to realize that. They realize the utility of overt errors. So, for instance, you point to things that have no relation, perhaps, to climate, but have the capacity to frighten people. Wildfires, extremes, obesity, autism, God knows, you'll have all of them associated with climate. And what is the implication? I think the people saying this know it's nuts. But the implication somehow is left that if they weren't misrepresented, they implied decarbonization. And so you could skip over all the logical steps that would be needed to do that and establish that if you see people getting fatter, it means you have to get rid of carbon dioxide. Keep the skeptics busy pointing to errors in things like climate sensitivity, while not questioning the narrative that the greenhouse effect determined major climate change. I'm as guilty as anyone of this. You know, you looked at the feedbacks and you said, these don't make sense, we don't know enough, and so on. And you forget that climate sensitivity calculated this way may not be the relevant thing to do. I have to give credit to Tony Heller, who quickly realized this because of a very simple thing. I mean, he was not into dynamics, but the climate of the Earth has dozens of climate regimes. How did one number correspond to sensitivity of this system to anything? The appeal to the insecurity of non-scientists is very important. A vast majority of the population cannot deal with graphs, numbers, and so on. We know this, and know it at the university from our humanities colleagues. So you appeal to their insecurity. They feel insecure about this by providing simple to understand narratives, even if they're wrong. So, for example, when an Al Gore tells you CO2 is a blanket, that's a lot simpler than what I've been telling you. And its simplicity is a source of comfort to the scientifically illiterate. Okay, so where does this leave us? Well, humor is always a potent weapon, and we use that often. And I won't dwell on it much, but at MIT we have somebody who's anonymous called the Babbling Beaver. The beaver is the mascot of MIT. And he makes fun of what we're doing there. MIT is gathering our librarians to train climate catastrophists to control Wikipedia's narratives, and describes this in detail as a crazy thing MIT is doing. Some approaches defy parody. We make fun of the Medical Association, but this one I don't think you've seen. Came from a friend who is a professor of musicology, and it's a forthcoming meeting in Essen, Germany on music and climate change, artistic action in times of crisis. I could read it to you, but I don't think it would help you or me understand what the hell they're talking about. Inconsistency obviously doesn't matter. The Boston Globe, I think, 2 days ago had the following. It was describing the fact that we had a cold spell. It was really very cold, and 3 or 4 hospitals, I think 3 hospitals, had broken pipes, and they couldn't admit ambulances with emergencies. And so they were saying, here's an example of how climate is preventing health care. And then what do they conclude? Well, unfortunately, I have to go back. Can you go back on this? Yes. You can't see it. Somehow the slide screwed it up. Their conclusion is climate change is stealing New England's winters when they've just been talking about frozen pipes. I don't know. In any event, ordinary people do remain skeptical. For obvious reasons, the things that they're presented with are kind of nuts. The educated elite seem most vulnerable, and people have mentioned Orwell, and he did famously say there are some things so stupid that only intellectuals could believe it. And there are reasons for that. I mean, what is the good student except the person who can rationalize whatever the professor says? So, but in any event, I think people in general of goodwill do want to believe that their government is not out to get them, which may be a false wish. There follows my take on the issue from 31 years ago, and I'll read that to you. Such weak predictions feed and contribute to what I have already described as a societal instability that can cascade the most questionable suggestions of danger into major political responses with massive economic and social consequences. I've already discussed some of the reasons for this instability: the existence of large cadres of professional planners looking for work, the existence of advocacy groups looking for profitable causes, the existence of agendas in search of saleable rationales, and the ability of many industries to profit from regulation, coupled with an effective neutralization of opposition. It goes almost without saying that the dangers and costs of those economic and social consequences may be far greater than the original environmental danger. That becomes especially true when the benefits of additional knowledge are rejected and when it is forgotten that the improved technology and increased societal wealth are what allows society to deal with environmental threats most effectively. The control of societal instability may very well be the real challenge facing us. This was 1992. Well, we're now in 2023. We failed to control the societal instability. However, the pain, the evil, and evident uselessness associated with the proposed policies seems to be turning the tide. After all, normal people will, one hopes, want a second opinion before being forced to suffer, especially if the suffering serves no environmental purpose, regardless of what one thinks about climate. Thank you.
Before I open it for questions, I'm going to share an anecdote because I was listening to Dr. Lindzen, and you have to know me and my father's relationship. He's very proud of me. First in college, got a PhD, and he knows, politically where I stand, and he knows politically where he stands, and so he calls me up and gives me a hard time every so often. And he called me up one day, and he had heard on the news about a new study that shows that climate change is increasing impotency among men. He says, "Now do you believe? Now do you believe?" He just cackled. He thought that was so funny, like that was going to all of a sudden change my mind. So, note on questions. We got plenty of time for questions. I want to get through as many as possible. So, I will recognize you. A monitor will come over with the speaker. I ask that you stand. Identify yourself, ask the question to a particular speaker, but there's no follow-ups, there's no statements. We want to get through as many as possible. Nathan, could you please go him and then
I'm Manali Darakshani from New York. This is a question for Dr. Lindzen. I agree with you that the educated elite are the most prone to alarmist propaganda. And it seems to me that the most compelling argument to the educated elite is the alleged 97% consensus among climate scientists and scientists more generally. And it seems to me if we want to make headway with the educated elite, we have to do our absolute best to convince them that they've been lied to about this particular consensus by reputable organizations, allegedly like NASA and the United Nations and so on and so forth. Do you agree with that?
Not entirely. At a more cynical level, I think nothing will help the educated elite. But there's also another problem, and that is who speaks for NASA, who speaks for these organizations. I mean, I have personal familiarity with some of the modelers. I know that they know that their models are in fact producing net benefit. They can't stress that to the funders. The work I did on the iris effect was done with NASA. In all these organizations, the names are used to intimidate the people who are not familiar with the details. Even the IPCC, Steve Koonin has this book, which I think is very fine. It has nothing to do with making a scientific case for no warming. Rather, it's saying, what does the official documentation say? So you go to the scientific section of the IPCC. Does it speak of an existential threat? No. It speaks of something very modest. You go to all these documents, and it's the things you've heard early in the meeting, these trends are not occurring, and so on. So the question is, this 97%, yeah, it's a number people like to quote, but he's pointing out the documents that they're basing this on don't say anything of that sort. So when you start attacking NASA, you start attacking NOAA, and so on, there will be an official there that may justify your attack, but very often their documents don't.
Bill Lindquist from conservative Marin County, California. Question for Ross. Ross, do you know, are there any plans to hold the EPA along with yourself and several knowledgeable real scientists before one of the House committees in Washington to question the EPA and have them defend the information that they've come up with that are determining a lot of these false policies by the agencies?
I'm not personally aware of any scheduled hearings. It would likely be a possibility in the current Congress, but there are some people here from Washington think tanks who would be more likely to know if any committees are planning to look into that.
The statement was that the House Commerce Committee is planning to do that.
Hello, Sean Bigler, gentleman farmer, Gainesville, Zone 8B. So my question is, as a layperson, I want a question for Ross. I want some real-life examples of the social cost of carbon. Bring it down to an individual or, regional or demographic level, something that I can understand, and then I would like to propose a future study. What is the social cost of carbon zero?
The studies that are done that try to come up with the social cost of carbon, sometimes they look at things like, let's say in a warming climate, you're more likely to have longer heat waves, and that can damage agriculture in some regions. So a lot of them, though, are much more speculative than that, and they just look at large-scale correlations between economic activity and temperature. You know, does productivity go down in really hot weather? And then as far as the social cost, if you mean by the social cost of going to net zero emissions, yes, the mitigation policies are extremely expensive. Even small-scale mitigation is expensive, and that's why the integrated assessment models keep coming back and saying, okay, you could justify eliminating the lowest value emissions out of all the economic activity, but that's very little, and the rest of it you should be prepared to live with.
Richard would like to get in on
Yeah,
that as well.
I have a question, Ross, and it's always bothered me a little bit. Where does the fact that rich societies deal with disasters better than poor societies enter to the calculation of the social cost? Because if the policies render us poorer and weaker, they're certainly leaving us less resilient. How do you factor that in?
Well, looking specifically at the agricultural literature, in the fifth assessment report, in the chapter where they looked at these studies of the effect of warming on agriculture, they went to the trouble of drawing two lines for each region. One was the studies that assumed there's no adaptation, and one was the studies that assumed adaptation. And of course, if you assume adaptation, then the warming is pretty much benign and has no cost. And if you assume no adaptation, then yes, warming is a problem, but everything's a problem if you don't adapt. So I don't know why people bother doing studies where they assume there's no adaptation. You wouldn't survive the transition from summer to winter if you assume no adaptation. So just on a basic level like that, yes, people will run all kinds of studies where they make assumptions that even wealthy people don't bother adapting. But once you admit that adaptation actually eliminates most of the downside risk, that raises the obvious point that, well, then the best thing would be for low-income countries to grow and increase their income. And that was an argument that Thomas Schelling made back in 1992 when he did his American Economic Association presidential address, and he went through all the consequences of climate on the economy, most of which you could dismiss because most economic activity happens indoors. But to the extent that it happens outdoors, his conclusion was the best thing really would be for poor countries to become rich.
My name is Carr Ingham. I'm from Texas, and I'm an economist with the Texas Alliance of Energy Producers. The regulatory structure in D.C. and within EPA and the Biden administration in particular seems to be, if not pivoting to methane, certainly a heightened, much higher focus on methane. They're quick to point out that its warming characteristics are vastly greater than CO2, but slow to point out that its concentration in the atmosphere is much lower. But both from a physics and economics perspective, I'm wondering about methane in and of itself as a climate danger, and whether or not there's any remote justification for this heightened focus on methane regulation, attaching a fee to methane from oil and gas production and then on down the stream. I mean, this is what we're looking at, and this is what oil and gas producers and others involved in that industry are presently facing in terms of regulatory threat.
Is Will Happer here? No, he should answer that. Yeah, I think that would be advisable. Will has studied that.
Put the mic over to Will. It's Professor William Happer of Princeton Emeritus.
Well, let me try and say something without.
He's getting your microphone there.
Yeah, per added methane molecule, one methane molecule is worth 30 roughly, CO2 molecules. So yes, it's 30 times more effective per molecule than CO2. But as I think the gentleman pointed out, the rate of increase of methane is much slower than CO2. Methane is increasing 300 times more slowly in the atmosphere than CO2. So you divide 30 by 300, you get 1/10. So methane's contribution to warming, and whatever it is, it's about 1/10 that of CO2. Now, the other thing about methane is that it doesn't last long in the atmosphere. It's got a lifetime of about 10 years, 8 years, something of that order, because it gets oxidized, it burns. And so the IPCC, as is their wont, says, well, we can make that into an amplification mechanism, so we might be able to double the effect of methane because if it oxidizes up in the stratosphere to water, which is a very potent greenhouse molecule, the most, then it will amplify the effect. So they're able to make that number of 30, maybe 40 or 50, but it's still trivial. So the answer is that there is no reason to regulate methane.
The gentleman, this gentleman in the white has had his hand up forever.
Just let me hold on. Hi, Ron Birdie, Free State of Florida. In Fred Singer's last book, he mentioned that there was we really don't understand natural variation. There's been no money put in it. I was a little surprised to read that from Fred. Is that your understanding? Do we not understand natural variation? Have we not studied it at all?
Well, the answer is no, we're not totally ignorant of it. You have all sorts of things, the Atlantic multi-decadal oscillation, ENSO, El Nino. You have many phenomena that go over periods from 4 years, like El Nino, to ocean circulations that might be on the order of a millennium. We know they're carrying heat toward and away from the surface. The surface is not in equilibrium. Sure, a lot of things about natural variability are known. We know that there are things like the quasi-biennial oscillation in the stratosphere, which is saying that the average period of the circulation there is about 26 months. We know the models don't replicate it. So you're caught in a situation where, for example, you use a model that has no natural internal variability to estimate how much it'll change. No, we're not ignorant of it. We do know the models understate it, often completely miss natural internal variability. We know that nature has internal variability that's profound. Look, the sunspot cycle is 11 years. It's a big cycle. Is it forced from something? No, it's internal. Our magnetic field reverses every so often. Is that from some external force? No. Internal systems vary by themselves. They don't need any forcing. And we know that.
The social cost of carbon is obviously being used as a weapon, in justification of radical changes. One model that we used to think of as the reality check is the EPA's own MAGIC model. Would you comment as to the value of the MAGIC model as a contra to some of these other models?
The MAGIC model, as I understand it, is a very simplified climate model. So you can run scenarios in it and get a handful of aggregate global average measures out of climate outcomes. So in that sense, that can be used as a way of checking the simplified climate models inside the integrated assessment models. it may have been done, but I'm not sure that it's actually been done. And it is something that's on my to-do list. A colleague in the UK has written about problems in the integrated assessment models that they get not just too much warming, but it happens at the wrong time. And so I mentioned the Rowe-Baker distribution. Gerard Rowe actually wrote an article a few years ago criticizing the use of integrated assessment models with high climate sensitivity, because he said the magic type models, you can have a high climate sensitivity, but the time to adjustment or the time to equilibrium then stretches out a long, long time. So it might take 1,000 years to get that much warming to happen. Whereas in the integrated assessment model, if you increase the climate sensitivity, it'll give you a lot more warming, but on exactly the same schedule. So the warming happens way too fast in integrated assessment models. I haven't really seen much being done on that point, but it's a good point, and I think the climate component of integrated assessment models really deserves a lot more scrutiny.
By the way, Bruce Everett at the CO2 Coalition has I think, a code available to anyone. It may even be a simple spreadsheet. These integrated assessment models are not very complicated. Any of you can run the DICE model on your PC or Mac and fool around with the different parameters involved. And the point of Bruce's code was to show you you could get any social cost of carbon you wanted.
This is, we're quickly running out of time. This is going to be the last question.
You have to, okay, thank you. Just an observation I'm Ben Zeiker from the American Enterprise Institute. Ross, on one of your slides, you had just a very passing reference to the use to some economists arguing that for a discount rate lower than 7% on the grounds there's a long time horizon. You know, because you're a much nicer person than I, you really didn't mention how venal, really what they're arguing is that intergenerational equity requires that. And as if future generations would be better off inheriting a capital stock less valuable rather than more valuable. And just to demonstrate how venal it is, if you look at the regulatory impact analyses from the Biden administration, they use a 3% discount rate applied to the benefit stream, but a 5% discount rate applied to this cost stream in these proposed regulations. And so they're biasing the analysis in favor of the benefits rather than the costs. It's really much worse, frankly, than you have suggested.
Back 15 years ago or so, the Stern Review came out from the UK government, and the Treasury expert, Nicholas Stern, argued for very aggressive emission control policies on the basis of an analysis where he had a discount rate extremely low, about like 1.5% or below that. And he took a fair amount of criticism from people like Nordhaus, but also Amartya Sen and other of his colleagues, who pointed out that if you use that kind of discount rate, you are privileging today's wealthy at the expense of tomorrow's poor. Mm-hmm. And it's the distributional consequences of using an extremely low discount rate are it's an approach that we wouldn't take in today's world. We wouldn't want policies that deliberately benefit the rich at the expense of the poor, although I say that and I think, well, that's what most climate policy does. People seem to like it quite a bit. But in principle, you don't want to be doing that, and that's the downside of an extremely low discount rate.
Yeah, climate policy is the transfer of wealth from the poor and rich countries to the rich and poor countries, right? Thank you. Sorry for my inadequate introduction, but I want to take time to thank our speakers. This panel is climate science scientific? If that's not the panel you intended to be on or be watching, you're in the wrong room. What can one be implying when you ask the question, is climate science scientific? Because, I mean, To the average person, the answer is, you said climate science, so ipso facto, it's science, it's scientific. But of course, that's not the way it is. In my experience, and I'll be brief, when I lecture at universities or high schools, or even middle schools on occasion, I always ask the students, how is the scientific method supposed to work? And I say, you have a phenomenon you want to explain, you propose a hypothesis, you develop a theory, and you test it. And if the testing, the theory seems to be confirmed, the more your provisions bear out in the real world, then the more likely it is true. The more it's disconfirmed, your tests fail, your theory repeatedly fails the test of reality, the less likely the theory is to be true. I said, is that how the scientific method is supposed to work? None of the students ever say, no, you got that all wrong. I say, and yet that's just not how climate science works. When it's tested against the real world data and it doesn't measure up, they say, we've got to fiddle with the data. We've got to adjust the facts. The theory is never abandoned. And so this is a very timely presentation. Our first speaker today will be Dr. Tom Sheahen, Chairman of the Science and Environmental Policy Project, longtime senior analyst at the Systems Integration Office at the National Renewable Energy Laboratory. Tom will discuss a topic near and dear to my heart, when scientific method is or requires and how it should be applied in climate science and climate models. The second speaker on the panel is Dr. Howard Hayden, Cork to his friends. He's Professor Emeritus in Physics at the Department of the University of Connecticut, the editor of The Energy Advocate, a monthly newsletter promoting energy and technology, who will discuss inconsistencies between climate model outputs and measured data, which is what I was just talking about. It should be noted that although Howard is just examining the inconsistencies contained in the latest, supposedly best generation of climate models, the climate CR6, what the failures that he attacks there, or that he points out there, are failures of all the previous models as well. They're supposed to be getting better, they get no better. Finally, with very brief comments, will be Ken Haapala, President of the Science and Environmental Policy Project, compiler of the Week That Was newsletter, and a contributor to the reports of the non-governmental International Panel on Climate Change. He'll discuss the IPCC's continual errors, which seems stubbornly unwilling to correct from report to report. Last housekeeping note, at the end, I will identify, we'll take questions. I'll identify you. We have a moderator, Samantha, who will bring a microphone over. Please stand up, identify yourself, and ask the question to one speaker, and there will be no follow-ups and no statements. Please ask a question, because we want to get as many questions as possible. We're already going to be short. Thank you very much. I'd like to introduce Dr. Tom Sheahen.
The title that I've given my talk goes under the name Data Trumps Theory. And if you've ever played bridge, you know what trumps mean there. And what essentially I have to say is that data is the overriding and ultimate arbiter of any theory there could be. So let's see.
Do you have the button?
Yeah. Green is up here. Good, okay. No, I didn't go forward. What am I doing wrong? There we go. Oh, and got to hold it up. All right. There's a basic rule in science that absolutely dominates everything. Any theory you can possibly think up has to conform to the data, or else it'll be dismissed. The great Richard Feynman said famously, it doesn't matter how smart you are or how beautiful your theory is, if it doesn't agree with the experiment, it's wrong. And you're supposed to say wrong with a Brooklyn accent. However, That's the cornerstone of science. That's what the scientific method means. And it's been true for centuries. What am I doing wrong here? Yeah. Okay. Long, long ago, thousands of years ago, Aristotle, on sort of a philosophical viewpoint, said that a moving body tends to come to rest. And that was plausible at its time because he never thought about friction. It didn't occur to him. Some 1,600 years later, or AD 16, Galileo went out and did measurements. That was unusual. It used to be you just believed philosophy. But Galileo made the experiments, took data, and showed that Aristotle was wrong, which is a perfect illustration of the fact that data is superior to theory. The law of inertia was composed by Galileo, which is that a body in motion stays in motion with a constant velocity unless it's acted upon by a force. And with a slight change in words, that's what Newton's first law is. Now, more recently, it was widely believed about the year 1900 that classical mechanics was perfect, and it described everything. Famous line about if you knew the position and momentum of everything, you could predict the entire future of the universe. But around 1880, discrepancies started to creep in because they couldn't find the way light behaves. Eventually, it was noticed that the idea of an ether was impossible, and space and time actually contract. So for high-speed particles, you needed an improvement, and that was what came along with Einstein's special theory of relativity. Eventually, that was generalized, the general theory of relativity. But astronomical observations were what was driving the demand for a new theory. Eventually, and today, we now understand gravity as the curvature of space-time. That sure wasn't the case around the year 1900, but we have improved the theory because we need it to fit the data. Now, this is attributed to Mark Twain, but nobody's quite sure if that's true or not. A famous aphorism: "It is easier to fool a man than to convince him he has been fooled." And you'll see later on that that's what we're up against. The important lesson that we have to keep in mind is that no theory is ever final. You can't have a final theory. Always subject to corrections, always, always, always. New data, if it shows a discrepancy, has to be taken into account. So that a new theory is supposed to encompass the old. Now, the same thing holds true in other fields, not just in physics. Chemistry, does anybody remember phlogiston? You have to be a historian of chemistry to remember that one. Biology. DNA now, since the 1950s, explains genetics, but that wasn't always the case. We have had in the last half century some tremendous computer-aided advances. Have these intractable problems that you can't do with either pencil, paper, a slide rule, or anything, but computer models will do it. And I give some examples here of CT scans, magnetic resonance, a few things like that. The proper use of a model is to test a hypothesis. Okay, and that's something that's very, very important, is you have to have proof. And in particular, you have to validate any model you think up. And the way you validate a model is by comparing it with the data. If you go into the business of trying to predict the future, you're in grave, risky territory because you don't have data for comparison. And if a model doesn't apply, how are you going to know that ahead of time? Contemporarily, there are a tendency to make predictions, and this is not just climate, but a lot of things. You are at risk of falling in love with your own model. The ancient Hindus had the idea that idolatry is to confuse your model with the real thing. And people do that. You fall in love with your model and you forget that reality is more complex than any model you can possibly dream up. So the future brings about what we'll call the test results. Future tells you whether or not your prediction was any good. And I noted there, if you know, in a situation in your model, the crash test dummies get killed, nobody minds. But if you're dealing with real people in the real world, you can make erroneous predictions that result in terrible consequences. So you really, really have to make sure you validated your models. So there have been various examples of these terrible consequences. There was something about 1972 called the limits of growth model, and nobody knew at the time of the existence of the mathematical condition called chaos. Chaos wasn't really discovered until 1984. But what was going on in this famous model, the limits of growth, was in fact chaos. It was coupled nonlinear differential equations that dealt with things like human population and disease and all kinds of things, food supply, etc. They put them all into this big computer model, mixed them up, and came out with some numerical results. And in one case, they got lucky, and they used that forecast to assume that they were going to have a stable population 150 years hence. But it was all nonsense, because they didn't understand chaos. But however, and this is a very big fact, the UN went ahead and made policies affecting the distant future based on that model from 1972. And they didn't understand the chaos either, and these policies, many of them are still in effect. So, if you try to model the contemporary climate, you get into, we all know of the greenhouse effect. It's been known since 1859, John Tyndall. But specifically in 1979, the Charney report set the basis for all the modern models. They said that CO2 was the control knob. The CO2 is what determines temperature. That was a fundamental assumption, but it was basically an adaptation of weather prediction models. Well, you had by this time some pretty big fancy computers, made general circulation models in the 90s and so forth. And as you got more and more powerful computers, you got fancier and fancier models. But the water cycle was ignored because they had placed their emphasis on CO2. And that continues to be a problem in the models to this very day. The reason they ignored the water cycle, it was just too hard to calculate. There's water, there's clouds, there's all this heat transfer and everything going on, too tough to include, so let's leave it out of the model. Huge mistake. We're now at a point where the IPCC, if anybody doesn't know this, they're split into 3 working groups. Working group 1 deals with the science. Working groups 2 and 3 deal with what's going to happen and what to do about it. But our enterprise here in this group is always focused on the basic science. They had these representative concentration pathways, or RCPs, and the reason they did this was to standardize the models between other models. They could compare each other by choosing these RCPs. So they devised, I think along about AR4 or AR5, what they called CMIP, Computer Model Intercomparison Project. But instead of comparing the models with data, they compared them with each other. Let's find a consensus, never mind the data. Another huge mistake. And that has created pressure upon contemporary modelers to not stray very far. Because if you do get a result that's far from the consensus, you basically are shunned, banned, canceled, ignored. Public policy, meanwhile, causes a great deal of fright. It causes people to be afraid. People are worried about what's going to happen next, etc. But what happens is, of the 4 scenarios, they deliberately chose one to be too small. Good idea. Makes a boundary, a guardrail on the side. They picked two that kind of made sense and were plausible, and then they picked one to be too high for the same guardrail reason. They wanted to have something outside the range of possibility so that all the models would stay well inside that border. But when they reported the results, they reported all four of them. Well, the journalists and the public didn't know anything, so they just latched on to the most draconian and horrible one, which was the one that was outside the realm of possibility. And they made headlines out of this. They got a lot of attention, caused worry among the people, etc. And that's something that has persisted to the present day, too. But here's what happens. John Christie showed this picture in 2015 to Congress and got some attention. The red line is the average of lots and lots, 102 climate models. But the serious data, which the model should have compared with, is shown by the green and blue down at the bottom, which has to do with balloon and satellite measurements. And that's another example of overlooking your duty as a scientist, to stick within the scientific method and to actually compare your model with the data. So, why is there climate alarm? Well, it's that media distortion. You don't get a headline, you don't get above the fold unless it's alarming. Politicians, they haven't got any technical acumen, so they pass laws against CO2 because the hype and so forth was telling them to get rid of CO2. We have student protests, Greta's name comes to mind. Businesses have caved in to meet the demands and promised such and such to the leaders of the movement. And all of this alarm was totally unnecessary and pointless because the IPCC recently realized that all this stuff was getting out of hand. Climate change has turned into a secular religion, and the idolatry that I spoke of before is believing that the models are the reality. Again, a huge mistake. The attempt by the IPCC in the last few months to curtail this alarm has a limited amount of value because the word hasn't gotten around yet. But what they did was they made it clear to anyone who would listen that RCP 8.5 was too high, and it's not to be used for predictions. And the remaining scenarios, RPC 4.5, 2.8, or 6, whatever it is, they don't give you a cause for alarm. They don't make any headlines. So there's a big industry out there of people drawing an awful lot of money from government grants mostly that hasn't got anything to do anymore. Well, these people find that it's best for their interest to not pay any attention to what the UN IPCC just said. So the next question is going to be, how long is it going to take for this news to penetrate all these barriers that are put up artificially? There's an aphorism attributed to Mark Twain a century or so ago that goes, "It is easier to fool a man than to convince him he has been fooled." And this is exactly what we are up against now. In trying to oppose climate alarmism, we are trying to tell people that they have been fooled. And there's a lot of resistance to believing that. The persistence of UN commitments to this very day, based on that old report, The Limits of Growth, is an example of this. And it's really a shame that this is being allowed, but it's the way public perception works. So to correct these deficiencies, we have to, everybody, not just we, the whole public, everybody, has to realize the deficiencies that are inherent in modeling. The input assumptions are what always drive a model, and those just cannot be perfect. You never should think that one parameter, such as CO2, can control the entire climate. It's too complex. You need to consider alternate causes like sun output, albedo, etc., and just realize that any computational effort that goes out into the future may well become chaotic. So it behooves you to include dissenting information inputs. If we're going to restore the scientific method, We have to remember that data is supreme over theory. Every model needs to be validated against the data, not against consensus. And a lot of data is now available from recent sources. We've got balloon data that's over half a century, about 2/3 of a century. We've got satellite data that's over 40 years. So it's possible to now make these comparisons with data. So thank you very much. And I think you will hear in the next speaker, Hayden, a very interesting story about a specific error that is in the IPC models that deserves our attention. Thank you.
Okay, good. Greetings, glad to be here once again. We're going to give you a little bit of an exercise in IPCC's self-contradiction. So a couple of introductory notes. I will not tell you that my climate model is better than the others. I don't have a climate model. That's model inequity. There ought to be a law. I'm going to be using intellectual jujitsu here. And intellectual jujitsu amounts to using IPCC's analysis and data against IPCC's analysis and data. And I apologize to the giants in our field, many of whom are in this meeting, that their data is probably better than what the IPCC has, but the intellectual jujitsu paradigm requires that I stick with the IPCC data. I'll begin with some terminology here, which is a little bit confusing. I don't know if it's deliberate or stupid, but in any case, you'll see at the top there it says radiative forcing delta F in watts per square meter. That's very curious because the delta would imply that it's a change in radiative forcing, but they just use the term radiative forcing. And right away, you begin to have a little confusion. So I'll show you a picture which sort of indicates what I'm talking about here. That sounds pretty ominous, but here's the picture. There's the greenhouse effect, and there's radiative forcing. The greenhouse effect from the IPCC is 159 watts per square meter at the present time. The radiative forcing due to doubling CO2 would be 3.7 watts per square meter. That's a little over 2% increase. Another thing is that everything in the IPCC is referenced to the pre-industrial period of 1850 to 1890, and with apologies to paleoclimatologists and so forth, they're going to ignore all the dinosaurs and the PT extinction and all that kind of stuff. Okay, so everything is referred to that particular pre-industrial period. That's talking about CO2 in the atmosphere, the temperature rise, and radiative forcing. In other words, there was zero radiative forcing in the period 1850 to 1900. Now I'm going to, this is copied verbatim from the IPCC. Radiative forcing is the change, and I emphasize change, in the net downward minus upward radiative flux expressed in watts per square meter due to a change in external driver of climate change, such as a change in the concentration of carbon dioxide. Now, most ordinary mortals would think that carbon dioxide is not external, but after all, most mortals are not in the IPCC. Concentration of volcanic aerosols in the output of the sun. I'll translate this gobbledygook into this. That is, changes in radiant flux due to changes in greenhouse gases, albedo, and sunlight, all with respect to that pre-industrial period. Okay, now I'm going to show you a heat balance drawing from AR6. That's the, what do you call it, the something review, assessment review. Sex assessment report number 6, which was published in 2021. That's a heat balance diagram, and there are numerous examples of the conservation of energy in there. For example, the sunlight that comes to the Earth is equal to the absorbed sunlight plus the reflected sunlight. The net amount of absorbed sunlight equals the amount of radiation that goes into outer space in watts per square meter. The heat that goes into the air, into the atmosphere, equals the heat leaving the atmosphere. The heat that goes into the surface equals the heat that leaves the surface. So they have these examples in here, and there are a total of about a dozen numbers. In fact, I think I counted there are 12. But wait, there's more. There's a blank region in there. And what is missing there? Why is that region blank? They've got an arrow pointing to a nothing. Now I'm going to tell you about what that missing number is. What is IPCC's specialty? Anybody? The greenhouse effect. Do you agree? What number is missing from the heat balance charts? The greenhouse effect. I'll show you. It only took them 31 years to ascribe a symbol and a number to the greenhouse effect. I sort of secretly think that maybe somebody who wrote this particular thing was a bit of a climate skeptic, and he didn't want to say anything that the political masters would recognize as being contrary, so he wrote a very complicated paragraph. Or it could just be stupid, I don't know. Anyway, the greenhouse effect, G, is the numerical difference between the surface radiation and the radiation to space. And God forbid you should have it in a heat balance chart. But here you come. Here is this interesting paragraph from AR6. At this point, you'll notice it says the greenhouse effect G, and there down below it says G equals 159 watts per square meter. And down here it says sigma is the Stefan-Boltzmann constant. That, my friends, is the first, number 1, example of mentioning, in fact, it's the only mention of the Stefan-Boltzmann equation, which is not given, in 31 years of activity at the IPCC. We'll get back to that. You are going to see what the Stefan-Boltzmann equation is. But in any case, we're going to put that greenhouse effect in there where it belongs. It's 159 watts per square meter. Okay, there's 159, which is the difference between the surface radiation and the radiation to space. Simple arithmetic. Figuring out that the greenhouse effect is 159 watts per square meter, is the province of real experts like Will Happer and William Van Weingarten. And they may have slightly different numbers and so forth, but we're going to show you a little bit about that. Here is a visual explanation. The radiation to space, that's a spectral plot. It's intensity versus reciprocal wavelength to the right. The intensity of the radiation that goes to outer space on the left is equal to that nice, smooth, black body radiation coming off the surface minus the greenhouse effect. Okay? Very simple. Okay, there we go. So here's the conservation of energy. I'm going to give you two examples. The first one is that in equilibrium, the amount of sunlight that's absorbed, I in, equals the amount of radiation that goes to outer space, I out. And you can see there the difference between 340 and 100 is, or between 100 and 340, is 240. And down at the bottom, they see a little bit of an imbalance of 0.7. And, well, that's a big maybe. It's really, really hard to measure something like that. To give you an example, you can't measure that number directly. Imagine measuring the distance between your feet and the moon, and the distance between your head and the moon, and subtracting to find out how tall you are. You might find out that you are minus 680 meters tall. So it's a very, very dicey number, and you'll notice that these numbers are fairly uncertain. But here's the other equation, that I out is equal to I surface minus G. And those other things are internal energy transfers, which require a certain amount of expertise, but we're going to ignore them because we're simply going to take their numbers as answers, okay? So now we have two equations, I in equals I out, and I out equals I surface minus G. And those numbers that you see there are the ones that matter, and we'll proceed from there. Let's do the trivial algebra. Anybody in the 6th grade that can't do this algebra ought to be taken out and shot. I don't mean that. Teachers maybe. Anyway, I in equals I out, and I out equals I surface minus G. All we have to do is equate those two. I in equals I surface minus G. That's a very, very, very important equation. Now, we're almost there. Where do we get that number 398 that was in that graph? And the answer is we get it, it's calculable from the surface temperature. That's the most important thing to know. The second most important thing to know is that Stefan-Boltzmann law is the one that tells us. And then we'll show you later what the actual equation is. But the answer is that 289.45 kelvins, which is 16.3 Celsius, is the temperature that would give rise to that 398. You can always find the Stefan-Boltzmann law on the internet, but important rule, do not get yourselves wrapped around the axle about pretentious precision. In other words, you look at that 398 watts per square meter, that's, well, maybe it's as low as 394, maybe it's as high as 400. Got it? Okay, now we come to an important concept. What happens if I in remains constant as the CO2 rises? In other words, we have I in equals I surface minus G. I in equals I out, okay? I in is whatever we receive from the sun minus what's reflected. I surface, you calculate from the Stefan-Boltzmann equation, and G is what they tell you, okay? So there's I out. Now, if In remains constant, that means the left-hand side of the equation remains constant. Therefore, the right-hand side of the equation remains constant. And what that means is, if there's an increase in G, it has to be matched exactly by an increase in I surface. I mean, this is simple, okay? It's really simple, but ignored. Now, comes a challenge to your favorite climate guru, and you have to ask a polite question. Well, what about heat balance charts for the future? Because all of the assessment reports, with the exception of the first one in 1990, had heat balance charts. So here is the complete set of heat balance charts for the future. None. And that's important. So you might be seeing where you can make yourself a buck. What you've got to do is challenge your climate guru to make a heat balance chart for the future and put it in the form of a wager. You know, make it worth their effort. So here is a $10,000 wager, but it's for real suckers. And it works like this. I'll bet you 10,000 bucks you can't find even one heat balance drawing made for any year past 2021 in any IPCC assessment report. There is no such chart, and no climate scientist that knows anything would take you up on that bet. But here's one where they might take you up on a bet. $1,000 wager. Guru, pick a model, any model. Pick a time, any time. I don't mean tomorrow, but sometime in the future, okay? Now let me tell you something about models. The RCP has been put in the past, and now they use SSPs, but the graph there is showing the amount of carbon that might be emitted in the future, just depending on what kind of things politicians do and people respond. And this is a graph that has some RCP numbers in it, but it has a whole bunch of models based on those things. So by that last one, it was Arlo Guthrie. You can get anything you want at Alice's restaurant. You can get anything. Okay, so pick some kind of a model, any time in the future, and that model, you're supposed to find a heat balance drawing in the literature. You got 2 weeks. Alternatively, you can use the numbers from your supercomputer output to make your own heat balance drawing. They have to satisfy the conservation of energy. $1,000 says you can't do it. And let me tell you why those bets are safe. You got a bunch of people at the IPCC that come from wholly different backgrounds, and they know you got expertise in this, you got expertise in that, and so forth. And everyone just kind of trusts one another, and they don't talk to each other. So the first thing I'm going to talk about here is the equilibrium climate sensitivity. And by definition, the sensitivity is a temperature. It is the temperature rise to be expected from a doubling of CO2. Okay, so the ECS, according to the IPCC, is that the most probable value is 3 degrees. In other words, if you double CO2, the temperature will eventually rise by 3 degrees. But Stefan Boltzmann steps in and says, if the temperature goes up by 3 degrees, the surface must radiate 16.7 watts per square meter more than it does right now, or did in 1850 to 1900. We are, remember, going back to pre-industrial, post-dinosaur. IPCC says that the very likely range is 2 degrees to 5 degrees C, warming due to CO2 doubling. And that would give us 11.1 to 28.1 watts per square meter increase in surface emission. Caused by 3.7 watts per square meter increase in the greenhouse effect due to CO2 doubling. Remember the right-hand side of that equation? Those two changes are supposed to be identical. So anyway, you can ask your climate guru, did you know that the word gullible's not in the dictionary? That passes for humor where I come from. What? You increase the ability to stop infrared from leaving into outer space by 3.7 watts per square meter, but your model says that you're going to have an increase in temperature such that you have somewhere between 11 and 28 watts per square meter leaving the surface. That's in excess of what we have now. Put it in picture, there's your 159. That remains constant. Doubling CO2 adds 3.7 to the net IR blocking. 159 plus 3.7. But the 3-degree temperature rise would cause 16.7 more watts per square meter. It's a physical impossibility. It cannot happen. Now, a lot of people think that the laws of physics are polite suggestions. They're not. They're inviolate. Well, anyway, IPCC's models don't generally refer to equilibrium. Those graphs that they showed were, well, that's what happens versus time. They didn't get to the final equilibrium when, oh, just wait till the end. Okay, so we're going to take a look at those things. And I'm going to show you this graph that's copied from AR6. You notice that you can read the dates there. Notice that you can't read any other numbers. You notice that, right? They like to have low contrast micro fonts so that you don't look at the numbers. Anyway, the upper graph up there talks about the CO2 emissions. It's the same graph I showed before, except in the graph I had shown before, I had put in readable numbers. Okay, but down below we have 5 different examples, and these are called SSPs, Shared Socioeconomic Pathways. That has replaced RCP. And the SSPs are followed by a 1, a 2, a 3, a 4, or a 5, according to those 5 different scenarios about how much CO2 we would be emitting worldwide. Then there's a dash, and then there is the radiative forcing after that. Well, I'll get to that. You'll get to see it a little bit later. Don't worry about the fact that you can't read it, because I'll show you one you can read. In any case, the graphs down at the bottom, the little bar graphs, show you the consequences, the total the amount due to CO2, the amount due to other gases, and the amount due to albedo. Albedo is just the reflectivity of the Earth, which is presently about 30%. Okay, these are the numbers. SSP 1-1.9 means 1.9 watts per square meter radiative forcing from all causes. It goes down the list and down the list to the 8.5 there. You know, my father is a broken record and my mother is a broken record, but I'm all right. I'm all right. I'm all right. Okay, now we're going to have a look at one of those, or in a minute. What do I mean by the radiative forcing due to all causes? Cause one is the change in atmospheric CO2. Whoops, back up. Did it go backwards? Okay. Cause two is the changes in other greenhouse gases, including water vapor, methane, nitrous oxide, ozone. Some people think ozone is the parking lot in the campus. Cause three is a change in the amount of sunlight reaching the orbit, and the IPCC takes that to be 0. Cause 4 is any change in the albedo, which is the reflectivity of the planet. Okay, now we'll take a look at SSP 3-7.0, which was the fourth graph over that you saw on the right there. Up at the top, SSP 3-7.0, Model 3, that's SSP 3, with the total radiative forcing by 2080 to 2100, with respect to 1850, is 7 watts per square meter. Now, I'm going to add a scale. This scale right here that I added is the increase in the surface radiation in watts per square meter. So we have 7 watts per square meter supposedly able to block 20 watts per square meter increased radiation from the surface. Okay, somehow that's supposed to block an additional 20 watts from going into space. Want to buy a bridge? I'll show you a little bit more about him. Anyway, what's the meaning of the bizarre results? Whenever the increase in surface radiation exceeds the increase in the greenhouse effect, remember we're talking of a disequilibrium here, the radiation to space increases. And if the radiation to space increases, that means we're in a cooling period. So how can a minor increase in the greenhouse effect cause the surface temperature to rise so much that it now has to be cooling rapidly? Only the IPCC knows for sure, or maybe their hairdresser. Any geezers here remember those ads? Okay, now we're going to take number 1 of those charts, the one way over on the left. It's the lowest CO2 increase caused by the most intrusive, well-intentioned, of course, governmental prohibitions. And here it is. Model 1-1.9. 1.9 watt per square meter additional blocking and 7.6 watts per square meter increase in surface radiation. It ain't gonna happen. They get the George Santos Award in resume embellishment. Okay, now here's Al Gore. This is the kind of iconic picture of him walking in front of the graph showing the temperature and the CO2 going up and down together. And If you look at the numbers from CO2 and you calculate how much radiative forcing comes from CO2, it's in the range of 2 or 3 watts per square meter. But the increase in surface, or the change in surface emission, is somewhere around 30 to 40 watts per square meter. The climate scientists were not asking, where did the CO2 come from to cause that warming? Where did the CO2 go so as to cause the temperature to decrease? Now, you do not have to be a whiz kid to ask those questions. Somebody who's pushing a 60 IQ to the limit is going to know to ask those questions. Now, you don't have to be brilliant, but the climate scientists were silent. It takes a little bit more sophistication to ask, well, how did the Milankovitch cycles cause the CO2 concentration to change before the temperature did? Why did the temperature start to decrease when the CO2 levels were high? Why did the temperature changes occur before the CO2 changes? You believe in retroactive causality? Posthumous suicide, anybody? Don't worry, honey, I'll take a pill in the morning. So here's a take-home message. The IPCC does not, and I repeat, not, apply the Stefan-Boltzmann equation to their results. Therefore, they cannot construct heat balance equations. You, however, must do so, and here is your equation. If you're not writing it down, remember, I'm a professor. Emeritus, which means out of merit. Write that number down, write the equation down, and I'm going to show you how to use it. You're going to apply it just for example, just to show you can do it. Choose that temperature and see if you get the right I. If you don't, go back and get it again. The easiest way to do it, by the way, is to use Excel. And what you use in Excel to get 5.67 times 10 to the minus 8 is you type 5.67e minus 8. And to get 289.45 to the 4th power, you 289.45 caret 4, and it'll work. In calculators, you use 5.67 EXP or EE8, and then change the sign with plus minus. You can do it. Okay, we going? Okay, now just apply it to some other temperature, like a 3-degree rise. Subtract to find out the increase in the surface radiation. You'll find out it's totally incommensurate with what they were saying is going to be the increase in, or the radiative forcing. Now you understand how the world has been conned. Now there are some take-home principles here that I want you to know. Planetary heat balance says that the I out, the radiation going into space, equals the absorbed sunlight. The heat radiated to space equals the heat radiated from the surface minus the greenhouse effect. I out equals I surface minus, absorbed sunlight equals I surface minus G. And the radiative forcing simply adds to the greenhouse effect. Now this is not hard. You don't have to be a PhD. You can fool all of the people some of the time, and some of the people all of the time. And that's enough to set up a multi-billion-dollar climate crisis industry. Thank you for your attention. Okay.
Hi, I'm Ken Haapala, and I'm not going to give you a slideshow, but I'll just talk about a few things coming out of a new book written by Tim Palmer, who's called the great guru of global climate models. Here's his book, it came out in October, and it's called The Primacy of Doubt. One of the big criticisms we have with global climate models is you can't criticize them. They immediately say they're non-deterministic, dynamic, nonlinear models. Whatever the results are, they're not intended to be precise. As a result, they produce these spaghetti graphs of results like Hayden showed you a few minutes ago. If you pull one strand, they'll say, well, the reason why that's not tracking well is it depends on initial conditions, meaning whatever was the input at the time that they chose the input to be. And this has been a long problem that's lasted for many years, since the early 1990s with the IPCC. Tim Palmer, in his book, which was highly praised by two Nobel laureates, the one in physics for 2020 and one in physics for 2021, goes into the thinking, which is absolutely brilliant, that goes into creating these models. And he clearly writes the thinking in the first 4 chapters. Then he goes, in chapter 6, he discusses climate change. And this is where I ran into problems with the book itself. He has 3 general conditions coming out of models. One is, if you double CO2, you'll have an increase in temperatures running about 1 degree C or 2 F. And most of the people, I'm not saying all the people, but most of the people giving presentations in the scientific section really don't have a problem with that. That seems to be pretty much what will happen if we have slightly nudged world temperatures. If we slightly nudge world temperatures by China continuing to produce massive amounts of CO2. The second condition is that the warming will cause an increase in water vapor, resulting in another increase in temperature of about 1 C or 2 degrees F. This begins to give significant problems. As Richard Lindzen mentioned this morning, there is no great variation in temperature in the tropics. The tropics are the most humid part of the globe in general. And if you increase water vapor in the tropics, you're going to start winding up with a water vapor greater than, or a relative humidity greater than 1, meaning it is not going to happen. We take about over 900 locations coordinated throughout the world, set up 2 balloons, weather balloons, that go up to about 110,000 feet and measure relative humidity, vapor pressure, and temperature. They're not seeing this significant increase in water vapor that's necessary to have the second condition that is brought up by Palmer. So we're not going to see it. The third condition brought up by Palmer, in which we also have a problem with, is that you're going to have an increase in temperature of about 0.5 degrees C, 1 degree F, from a decrease in Arctic ice that will be the result of the increase from water vapor and the increase in temperature from CO2. As we saw this morning, there are very good reasons why sea ice in the Arctic fluctuates. And we have a history of it. You had a melting of the sea ice in the Atlantic in the 1920s, and that was possibly due to a change in currents, basically the Gulf Stream, the amount of heat from the tropics that was going into the northern Atlantic. We also see what is called the ocean blobs. Strong warming in certain special locations of the ocean. Joe Bastardi referred to this and says there's a climate wizard up there saying this part of the ocean is going to happen. It's not going to happen from CO2. This is most likely from undersea volcanoes that put out a lot of heat. One of them broke the surface earlier this year, exploded into the stratosphere, increasing the water vapor in the stratosphere by about 10%. That's a dramatic increase for stratospheric warming that has nothing to do with carbon dioxide. So I think with this book, Tim Palmer unconsciously brought out the great deficiencies in global climate models. And unfortunately, these will continue as long as the IPCC continues. Thank you.
Okay, so remember, raise your hand, stand up, identify yourself. Let's see here. One right here. Where's Samantha's coming with the mic.
Dennis Grove, Mr. Hayden, or Professor Hayden. It's been a while since I looked at detail at some of the IPCC's work, but one of the things that struck me at the time was they converted all of the other greenhouse gases into carbon dioxide equivalents. So I was just wondering, are you aware of that, or have you ever looked at that? I mean, when you're talking about greenhouse gas effect, it just seems to me that by treating everything as carbon dioxide, they've already kind of messed up the greenhouse effect.
Is this working? Well, I really don't see terribly much of a problem there. It's about like translating horsepower hours into calories. It's just in a way kind of a units conversion, but in the end they all want to be in watts per square meter, but the reason they do that is simply for kind of purposes of comparison. But I would prefer to just have everything in watts per square meter.
But they all observe differently, that's why
Well, yeah. Well, they have on a per molecule basis, they have different absorbing capabilities, and even there, it depends on what part of the spectrum you're in. In other words, if you're in a part of the spectrum where 2 or 3 gases absorb, then it's a little bit hard to compare it. Like what would happen if there's more CO2 and more H2O, in that part of the spectrum and so forth. But That's a pretty dicey thing, but in any case, from my standpoint, I'm willing to look at what they consider the total radiative forcing due to all those changes. And when the total radiative forcing due to all those changes is incapable of accounting for the increase in surface radiation, you can say straight off the bat, they don't know what they're doing.
Before we go to the next question, I'd just like to interject. In the graphic you showed on that,
yeah,
when it showed the bars and the radiative forcing, they had 4 mechanisms. 4. What they didn't include is volcanoes, oceanic currents, clouds. They threw out everything that they had actually included in previous reports as forcing mechanisms, either negative or positive. Every time they change the report, they decide new things affect or don't affect the climate, and we're going to just toss out the old. It's amazing. So.
Hi, I'm Rick Werma from New Hampshire. This is for Ken. One of my goals at this meeting here is to get some questions about the Honga Tonga explosion answered. And this may be going beyond what you were talking about here. But, okay, so it put 10% more water into the stratosphere through the whole stratosphere than was there before. How is that water vapor going to get out of it?
It'll eventually freeze out, but you're right about the event. That is a tremendous, that's what I was referring to, is started out as an underseas volcano, came through the surface and put out a heck of a lot of water vapor. The water vapor that's in the troposphere, which is below the stratosphere, that is forming in the Arctic, that will eventually freeze out. It'll take time. I really don't know how the stratosphere loses water, quite frankly.
I'd like to make a little bit of a comment on that. And that is when you have a very, very sparse atmosphere with a little bit of hydrogen or water molecule here and another one over here and so forth, it's very hard for them to get together. And in fact, up there in the stratosphere, the temperature may be so high that when they come together, they have no means to get rid of the excess energy, and because no internal mechanism will absorb that energy, and so they just go apart. For the most part, the radiation or the nucleation that takes place in the atmosphere with water molecules has to do with either dust particles or radiation tracks from cosmic rays that provide nucleation centers for the waters to get together. Once you've got 2, it's not so hard to collect a third, but those first 2 molecules is really quite hard. And up in the stratosphere, that mightn't happen. I don't know if you're aware that all of our helium comes from radioactive decay of uranium and other such radioactive materials. The helium, once in the atmosphere, rises and rises and rises and rises and goes on up, and eventually is just blown off the earth entirely by the solar wind. The helium is a good deal less massive than a water molecule. However, I think it's still possible that you can blow away water molecules to get high enough up there in the solar wind. They pick up enough energy from the collision simply to leave the Earth entirely. Fortunately for us, most water rises not terribly high, but precipitates when it gets up there where it's good and cold. But occasional sudden injection of water way up there, that's a whole different can of worms. I pretend no expertise in that, so.
Yeah, I'm Chris Essex.
Hi, Chris.
Hi, Cork. So I have a question for you. I didn't quite get why your variable G was a constant.
Oh, it isn't. It isn't. It's simply the present value. And the present value, according to IPCC, is 159 watts per square meter.
When you vary things, doesn't it vary too?
Oh, yeah, it could vary because it's due to...
But that's an essential part of your paradox.
Well, we're considering variations like what happens if we double CO2 and so forth. Those things which the IPCC lovingly calls forcing, unless it's a change in sunlight or albedo, it's either, it's a change in the greenhouse gases, and that change simply adds to the greenhouse effect. So the greenhouse effect, if you added 3.7 to 159, would be 162.7.
Okay, I want to follow up on this remark by this gentleman over here about the different effects of different molecules. In my earlier days, I actually did radiative transfer with a full equation of transfer and not just the Stefan Boltzmann stuff.
Yeah.
And it might be true that something like nitrous oxide has more greenhouse availability in a way. But when you do a full model and you put nitrous oxide in or take it out, it doesn't make any difference because it really depends on the bands that you're looking at. So if you're, well, I don't know, ozone like 9.6 microns or 15 microns or whatever, it makes a difference what the water vapor spectrum is doing because these molecules are competing with the water vapor for the available energy flow. And as a result, it's like they arrive at the party too late when all the food has been eaten and the police have come to break the place up. So you can put the same thing with methane. If you put methane in or take it out, it doesn't make any difference at all. Even the other bands of CO2 don't make any difference. So there's like something at about 4 microns. But the 15 micron band does make a difference because of the water vapor window. That's the only reason why we've ever heard of CO2. So it really matters what part of the spectrum you're in and not the individual molecule for molecule absorption in the infrared when you're doing the full radiative transfer calculation. Anyway, I think I'll leave it there because I could go on.
The gentleman in the far back.
I think one of the papers recently from Van Weingarten and Happer discuss methane and climate, and another paper discusses the relative potential, greenhouse potential of various greenhouse gases, and it covers it supports exactly what you're saying. If you add methane in today's atmosphere, it's not going to have much of an effect. The same with nitrous oxide, because it's already that effect is largely taken up by water vapor already.
Hi, I'm Dr. Matthew Wailicki from the University of Alabama. This is for any or all of you. My understanding was that one of the way IPCC gets around some of these imbalances is through feedback loops and different styles of feedback. Can you guys make any comments on your opinions on the feedbacks?
Well, yes, the whole idea of feedback is that, well, there are actually, I think, 3 different positive feedbacks. One of them was that if you increase CO2, then you increase evaporation, you increase the release of methane from the permafrost. And let's see, what was the other one? I can't remember. But in any case, CO2 does not cause any of those things. Heat does. Any heat from any source whatsoever. So that means that if those are particularly important things, then any change in heat from any source whatsoever should cause that same cascade of heating more and heating more and heating more and heating more, leading to disastrous consequences. And then you just turn around and ask, how come we're here? Because that kind of heat has happened thousands, if not millions of times before. And we haven't gotten to that devastating feedback where the Earth just gets hotter and hotter and hotter and is now the surface of Venus. Sir, you were going to say?
Hi. Bob Armstrong, cozy.com, COSY.com. This is actually sort of a continuation of an email discussion that we've had somewhat. My background is I aced high school PSSC physics, so I sort of look for solution or understanding that's at the AP high school level in some ways, and I compute. And one of the things that's most fundamental is there's this divergence theorem, which is second-year calculus, which says that if you have the temperature of a surface of a body, the interior has to be the same temperature unless you have an internal source of sink or source of heat. And so what is the source of the kinetic energy? Now, Hayden went and gave a good equation that says, I mean, one of the things is energy in has to equal energy out, exactly true, but the interior energy has to equal that of the surface. The interior energy density has to equal that of the surface. So where does the extra kinetic energy come from? And Cork even has the correct letter there. It's gravity. You cannot have a complete energy equation, energy balance equation, without including gravity. And in fact, the only complete equations that I know of for giving the surface of the planet, given the input of the sun, are from a number of people who've worked out what the gravitational energy is that is in adiabatic relationship with the kinetic energy.
Bob?
And that, in any case, so check that, you know.
Yeah.
That's, so any comments on that? G is gravity, and it must, by conservation of energy, be in the equation somewhere. So it's where, how do you account for gravitational energy?
Let me make a couple comments on that. But the G he's talking about is a little g, not the capital G. That's the greenhouse effect. That is, of course, taken into account by Happer and gang using what's called the lapse rate, which has to do with a decrease in temperature as you go up in altitude. Now, what happens is that if some air descends, we see this very commonly over in Pueblo, we get some air coming over the Rockies, and it descends, and we call that downslope heating. Okay, it's compressed. The air is compressed. But for every cubic meter of air that is compressed, that comes down, there's a cubic meter of air that goes up. Okay, that's what the whole lapse rate thing is all about. But the thing that causes heat when you compress is the pressure multiplied by the change in volume. It is not the pressure. Pressure is not heat. Heat is not pressure. Pressure times the change in volume. Okay? So Once upon a time, just imagine that the air was descending down on the earth, and it was just because it was getting closer to the earth, and the density was increasing, that caused some heat. 4.6 billion years ago, that heat left. That heat left. It's irrelevant. It's gone. No, it isn't. It's gone.
Well, that will be the last question. We actually got out, much to my surprise, on time, and we can clear the room for the next panel.
Okay. All right. Welcome to this exciting panel discussion we're going to have today on the green agenda and how it impacts people. We have some great speakers. What we are going to be discussing today is actually one of the things that I think is perhaps the most vulnerable point of the green left and of the whole climate agenda. I know a lot of you are saying, Craig, wait a minute here, it's the science. Hey, I'm not arguing that. I think the science is the underbelly and the thing that needs to be fought more aggressively than almost any other a part of this debate. But when it comes to actually defeating the left in a political way, I think this issue of defeating them because of what green energy in particular does to people and the environment is the soft underbelly of the whole climate alarm movement. You look today around the world at these countries that are going green. They are putting up wind farms. Where are these materials coming from? Yes, China. A lot of it the Congo, where you have oftentimes underpaid workers live in atrocious conditions. You have child labor being used, Uyghur labor in China also. You have just devastating things being done in communities around the country where these wind turbines I put in have displaced jobs, property rights being trampled upon, and all manner of havoc, which is actually starting to have a backlash. Robert Bryce noted, and he put some sort of figure, that the number of communities that are fighting back against green energy projects because of the impact on them has grown to dozens and dozens across the country. And there's also environmental impacts, and we're seeing some pushback from that, as I had mentioned in my earlier comments yesterday regarding the whales off the east coast of the United States and the impacts of these wind farms also on eagles. So we have with us today 3 outstanding speakers that are going to talk about this. It's Donna Jackson, and she's with the National Center for Public Policy Research, Bob Carlstrom from AMAC, and Margaret Byfield from the American Stewards for Liberty Coalition. And so saddle up. We got a good program ahead, and I'll get out of the way, and we'll get these speakers up here. The first one is a rock star in her own right. Her name's Donna Jackson. She, I guess, are you originally from California or just go to California? Yes, a California lady from who went to Cal State University at Santa Marco. She worked in accounting, auditing, and management with major companies such as Ernst & Young and Marriott International, and she was a deputy controller for the Export-Import Bank of the United States. She was also very involved in politics. She's a political operative, particularly in Arkansas. She worked on the successful campaigns of Governor Mike Huckabee, Senator Tim Hutchinson, and Representative, now Governor, Asa Hutchinson. Today, she serves as the Director of Membership and Development at Project 21, which is run by my good friend David Ridenour at the National Center for Public Policy Research. As I say, I've had a chance to see her many times in Washington. She's a dynamo, energetic figure, and I think you're in for a treat here. So come on up, Donna, and take it away.
Thank for that. I'm looking for the rock star. I guess they're here somewhere. No, but I'll take their place, okay? Yes, my name is Donna Jackson. I'm the Director of Membership Development for Project 21. We are the Black Leadership Network, one of the oldest and largest Black conservative think tanks in the country. I have the privilege of working with some of the most dynamic individuals that you've ever seen. These people have signed up for the fight. You know, somebody asked today, and I've heard it twice, what does winning look like? Well, one of the things I like to study is generals, military generals. And think of us as the Tuskegee Airmen. We come in and we're here to fight the battle. When the Union Army was looking for someone to come up and help them fight, they called the black soldiers. Here we are. So recently we've heard a lot. Recently I had the opportunity to testify before the Energy and Commerce Committee, twice actually in January. First was a affordable energy roundtable with all of the Republican members of the Energy and Commerce Committee. And the second one was their first hearing. And the reason why that was so important is because you hear a lot from climate change activists. You hear a lot from politicians that are all benefiting from environmental justice grants, but you don't hear from the individuals that are impacted in the community. If you went to an African-American community and asked them, what's the priority for your community? None of them would say climate change, not one. Despite the fact that you're hearing people talk about environmental justice. I'll tell you what environmental justice is. It's the black exploitation game. That's how you blackmail every American to fall in line and self-censor and not check on where's the money going. In the Inflation Reduction Act, there was some $60 billion advocated for environmental justice. I want you to realize what that equates to. That is equivalent to the market capitalization of Ford Motor Company International that employs over 200,000 employees, not including the countless indirect jobs from small businesses and vendors. And guess how much money is actually going to go into the black community? They'll get a few retrofittings and windows. And for somebody to sit there and say that somehow environmental justice is dirty air, I'll tell you what the biggest injustice is for black communities. It's poverty. But climate change activists have no problem creating environmental policies that create more of it. If you ask African Americans what is the number one civil rights agenda for the black community, is home ownership. But guess what environmental policies do? They create artificial scarcity by adding additional regulation costs by preventing the development of housing. So who's the enemy here? Now, if you ask me, how do we fight the game? Get African Americans and let them know how these environmental policies are affecting them personally. Black families have the lowest home ownership rates. 70% of black households are run by single parents, mostly females, but guess what? The largest demographic of individuals trying to start their own business is black women. But what do environmentalists do? They create regulations that penalizes small business owners. The Small Business Administration did a study, and what they said is this: small businesses pay 4 times their revenue towards regulations, including climate change policies, than big businesses. Every time they create a climate change policy, it favors big businesses and it squashes small businesses. The war on stoves, what do you think small business, the number one business force black Americans are? Restaurants. Can they afford to buy expensive appliances and convert their homes and their businesses to be able to meet these regulations? No. The whole goal is to put them out of business and create a permanently government-dependent underclass. These environmental policies are a way to usher in socialism, to take away the ingenuity of African Americans who want to participate in this great American dream. High energy costs create barriers for those trying to get out of low income and emerge into the middle class by increasing the cost of energy, increasing the cost of living expenses so that people don't have money to be able to save. The energy industry represents high-paying gateway blue-collar jobs for people that don't have a college education. Even the Washington Post, as woke as they are, said that green jobs that Biden claims is going to replace these jobs, right, only will fill 20% of the coal jobs lost. So now, all of a sudden, and this is a horrible statistic, in California, in 2009, 52% of people could afford an entry-level medium home, not anything lavish, just a medium level. That number is 26%. For Black Americans, 8%. 92% of the population cannot afford an entry-level middle-class home. When you hear people talk about the wealth gap, and you hear it a lot with African Americans, they're always saying that we want to narrow the wealth gap. How do you do that? Through home ownership. Who's preventing you from doing this? Rich, white, elite liberals that have created agenda for Black Americans that they didn't ask for. And they put justice behind it to actually push that narrative. Every person in this room, if you want to make an argument, make it hit home. Because African Americans can turn the tide of any election, any momentum, and all of the ESG that we see going on today. One protest before the 2020 election turned the whole government. I mean, we were living in the golden years when the Trump administration had energy independence. Who do you think got laid off from those jobs? They were Black and brown people. We had the highest home ownership rates. We actually had the highest entrepreneurs that started their own business during the Trump era. Today, all of that is gone with the Biden's attack on the Black community using climate change as the mechanism. What we need to do is let people know how this bogus junk science is being used to take away their livelihood. There was an interesting study with the Energy Information Administration. They said 1 in 3 households struggled to pay their energy bills. 1 in 5 had to give up food and medicine to pay their energy bills. That number, I want you to get this, double for minority communities. Double. So you have people that are sitting there making life and death choices because we have an administration who has attacked the fossil fuel industry, who doesn't care about individuals. He decided that Black Americans, despite using for a prop, are expendable. Black people are not, because of high energy bills, are not living paycheck to paycheck. You hear it all the time. They're living paycheck to Wednesday, and then they're borrowing money, and they're trying to get money from their families. They're living upside down just to make it to the next paycheck. So they're already behind. Explain and show people that in the name of bogus science, this is what they're doing to your life. You want an army? You get one. You get one or two leaders that are sitting there and saying, why can't we make it out of poverty? And you show them the connection between climate change policies that creates a slow growth economy that is actually demonizing industrial jobs that was responsible for creating a vibrant middle class, Black middle class in this country. It was Ford Motor Company, it was General Motors, it was all of these industries that created a Black middle class. And now what they're doing is deindustrializing the country, and who's losing the jobs? We are. Let them know who's doing that. And I can tell you right now, you'll have somebody on your side. Now, I guess there's some more I can say, but this is an opportunity for you to ask a Black person, a Black woman who is an evangelical Christian who says to you, don't filter your question, because it's important that you realize that we're in this fight together. And there are a lot of people, I get calls all the time, who are saying, help us. Home ownership is the new Black. And make sure that you get that message out to everybody so that where we are today, we can turn the tides, and we got 2 years to do it. And we can do it together if we message correctly. Thank you.
See, I told you she was a rock star, right? I feel sorry for you, Bob. You're next. You get to follow that up. Just to add what she says, one of the things we do at CFAC, she talked a lot on the domestic level. We do a lot of international work, and so believe it or not, CFAC actually puts up solar panels in Africa and in Asia, not Asia so much, but South America, and in poor communities. And people are perplexed by that. Why are you doing that? That means you must agree with the green agenda. I say, no, it's because they have no electricity. There's no grid there. The objective is that this solar helps them to get to where they need to be, which is bountiful electricity. You ask the people in the countries, these indigenous people, the left tends to look and say they want to live the way their ancestors did, 1,000 years ago, and in touch. And they can say that as they're sipping on wine, going down the Nile. Oh, look at the natives. They look so wonderful, No, they want jobs. They want electricity. They have the same hopes and dreams as we do in this country. And Donna, great presentation. Thank you. Next one up is Bob Carlstrom. He actually works with the AMAC, and that's a wonderful organization. And I guess they challenge you. I guess the good news is you guys go against the AARP? Is that your kind of alternate? No? Okay. Well, it's a good organization in this regard, is that they give you discounts if you get that AMAC card, which I have, which is kind of a plus and minus. I like having it. I don't like having it because it means I'm over, 55. So anyway, it means I have to actually admit I'm over 55. Anyway, he co-founded and built and led as chairman and CEO, one of Washington's largest independent government, international, and federal marketing consulting firms. He served as a managing director of the government strategies practice of a major New York Stock Exchange traded business consulting firm. In the political world, Bob served as the senior executive director in the Reagan White House Office of Management and Budget, where he coordinated and directed the administration's interagency review and analyses. And in 2016, he co-chaired a national coalition for the election of President Trump and Vice President Pence. Again, today, Bob serves as a president of AMAC Action, the advocacy affiliate of AMAC Inc. And welcome.
Now, I hope I do this right, but thank you very much for that introduction. It's so good to see all of you. Thank you for not going to the swimming pool and the bar and coming to this session. We appreciate it. But AMAC stands for the, and first of all, this is a tremendous conference. I wish I could be here for all of it, but the sessions we've been through have been great. You know, and Heartland is just an important, critical part, you know, of the public dialogue in terms of the issues of the day. So thank you for all that you're doing. AMAC stands for Association of Mature American Citizens. And we are that conservative alternative to that other organization that's gone left. We were formed as a reaction to that in '07. We launched AMAC Action as the advocacy affiliate of AMAC in mid-2019. And since then, we have been very active, not only in the Congress, but also in the states through our members, because it's our members that get out there and respond to our calls to action. We have now over 340,000 of our members individually respond and directly lobby, either federally or in their state legislatures at home. And we support those activities through our national grassroots activities. And so we've been extremely active on election integrity, because election integrity in the states is critical for the 2024 election. And so we're out there pushing hard on that, and saving Social Security, other kinds of things. In fact, we represent virtually all issues that affect any American, because we're grandparents and parents. And so we want to leave our nation better, you know, than what it is today. And so we fight the liberal challenges, and we don't wilt on the issues. And so consequently, I'm sure the Biden people have a different term for us. Do I press the green one? Okay. So anyway, the last other component of AMAC is the AMAC Foundation, where we provide free Social Security advice to Americans, any American, asking, what do I do about Social Security? What happens if I lose my spouse? All of these kinds of things. We have certified Social Security counselors, totally free. We do the same thing in the veterans area and in Medicare. So if you go to the AMAC Foundation, you can get there. So we get between 750 and 1,000 calls a month from people on Social Security. And so I urge you to take a look at that. Now, in terms of the impact of higher energy costs that have on the poor and elderly, and that's where I'm going to focus. You know, we've heard a lot in terms of the macroeconomic effects, but I think it's important in this debate to understand what has happened on the home front, particularly to those in the middle class, lower income levels, on fixed incomes and retirement, and what's happened there. Because it's important to get granular, below that. So the economic turmoil that's been occurring, since Biden took office, has left seniors very little wiggle room. And in fact, many have found themselves slipping into the poverty level. So I'm going to dig into that a little bit. Let's see. Okay. Jason Smith, the new chair of the House Ways and Means Committee, talks about, inflation's risen 13.9%. Many feel it's even greater than that, because the impact on the dollar has been enormous. Your $1 of buying power when Biden took office now requires $1.70 to buy the same thing. That's almost a 42% reduction in less than 2 years in the value of the dollar. So you can imagine, the impact that's there. You see changes in food products and things like that. The little bags of potato chips are smaller, things like that. Instead of an 8-ounce salmon steak, it's now a 7-pound salmon steak. So it really, really cuts across, and it hits first. And this has been the biggest inflation spike in 40 years. Another number on is inflation's at a 41-year high at 64%, and that's for interest rates. Real wages have declined. You can see that. The average mortgage payment's 28% higher. Interest rates in the last year have increased more than 15 years combined. And we all that have to thank is what I'll be getting to on that. So what causes inflation? And like so much of macroeconomics, when there's a sudden announcement, sudden changes occur, supply shocks can occur and lower the economy's output, driving up prices. An increase in money supply stokes demand when you look at all this runaway spending that's going on, and that drives up prices. And people expect inflation is going to be occurring, and it's going to be more difficult. And that cycle, also creates a self-fulfilling prophecy in terms of causing it. So Biden's actions causing inflation, I probably should refer to that as the third Obama administration, but we'll call it the Biden administration. First, his war on fossil fuels propels supply shocks and economic ripple effect, because energy is the basis. Low-cost energy has been the basis for our economic prominence and leadership in the world. He struck at the heart. That was a seminal act in spawning inflation. Secondly, in terms of the runaway spending, really demands a greater money supply. So the Fed, increases the money supply, accelerating more demand and therefore accelerating inflation. So the war on fossil fuels is, the rapid inflation. January 20, he takes office. The average price, you can see it there, was $238. But the supply shocks kicked it up immediately. And it creates a behavior in the economy called cost push inflation, because energy is a critical input in almost every other good. And so the prices of other things rise. And then the economic ripple effect, because petroleum, oil, and gas are critical for all components of the economy. And boom, there it goes. So the Biden war on fossil fuel, really, started with his executive orders, when he killed the pipelines, now that's almost 2 years ago, blocking permits on existing leases. They lied to the American people and said there are 9,000 leases out there that nobody's using. What they didn't say is we're not issuing permits. Yeah, so there you go. And the momentum, in terms of oil and gas activity, a moratorium rather, in the Arctic National Wildlife Preserve. So boom, they're clearly trying to shut down fossil fuel, and then he accepts the Paris Agreement. These international environmental agreements are really intended, the story behind the story on that is to squash U.S. competitiveness. It's from the left, from the boys in Davos and that kind of thing. It's intended to increase our costs so that we become less competitive, in the world market. And so the economic ripple effect begins, energy goes up, fossil fuel prices increase, and it increases the food, manufacturing, and residential energy. For example, and then you go through this chronology here. In terms of which you can see, proposes increased taxes on oil, calls on OPEC to increase production, therefore reduce U.S. production. There's no relaxation in this. November 10, inflation reaches a 30 high, and ultimately in March, the national average for a gallon of gas is $4.33. And the runaway spending is the evil twin, in this whole thing. $6.5 trillion in fiscal year 22, and a national public debt exceeding $31 trillion. In fact, exceeding GDP. That's awful. You know, it cheapens the value of the dollar. You know, think of Venezuela, you know, as a metaphor in this. You know, so, you know, Milton Friedman, great man, you know, it's always there and everywhere, you know, a monetary phenomenon. And so what's happened here in terms of the spending, increasing the money supply, you know, essentially is a push to put more money and more dollars out in the economy. The Fed loosens up the monetary standards and boom, you have this runaway inflation. So look at the current results. You know, gasoline prices are 76.13% higher from BLS, Bureau of Labor Statistics. Gas experienced an inflation rate of 33.84, fuel prices, et cetera, et cetera, et cetera. So you can see how those all go up. And so then we're looking ahead in 2023. So the elderly and poor, watch out. You know, in terms of, you know, a recession is being forecasted for 2023. You know, the Fed is trying to squeeze down by raising interest rates some more. Many people disagree with that. You know, we're going to have a tough year going forward. And those that are in the middle class and the lower income strata and fixed income are going to face a larger squeeze. Those that are more wealthy can complain about it, you know, but nonetheless, those in those economic strata are really going to be hurt. And, you know, and Biden refuses to take any real responsibility for that. So here, look at the average income levels in, how am I doing time-wise? Am I good? Okay. You know, the average income, you can see these here, the median income and that, and average annual expenses for adults. And then, but the monthly Social Security benefit is, you know, average is $1,681, and it's going to rise to $1,827. This is Bureau Census numbers. This is where we get into it. Now, retired income sources, you know, usually involve your financial assets, you sold a home, your stocks, your investment, a pension if you have one, unless you work for Enron. You know, Social Security, you know, since inception has become an increasingly important part of retirement income, and many in continuing employee are continuing to work forward on that. And by the way, we're trying to remove the penalty for people working and receiving Social Security as one of our many initiatives. Now, when you look at the median income again, you know, in the age of the household, 65 to 69, you can see those numbers there, 50,000, and then households age 75 and above, 34. So, and then how many seniors rely on Social Security for most of their income? You know, now 9 out of 10, 65 and older, receive it or are going to receive it by the time they're age 70. But among elderly beneficiaries and 21% of married couples, 90% or more rely on their income from Social Security. So here we go. You know, here's another one. Social Security is the sole source of income for about 1 in 5 or 20% people aged 65 and older. I think I misspoke on that one. This is the right one, right phrase. And that's a lot. That's a lot of people, you know, and overall, you know, Social Security, you know, keeps 22 million people out of poverty. So when you look at their other retirement income plus Social Security, they still are able to stay above the poverty line, but barely. So let's look at what national poverty levels are. You know, for a family of 2, it's $18,000. For a family of 3, let's say grandchildren are living with you or something like that, it's these numbers here. So anyway, so how much does Social Security ultimately pay on an average basis? And going back to the earlier chart, you can see these numbers here, you know, and so it's pretty modest, you know, when you look at the, and how close it is to the national poverty level. So, and what's happened, you know, in terms of the increase in the cost of living and the COLAs this last year and this year going forward, it still falls short by 46% in terms of what the rate of inflation is. And it's strange to hear this president claim success for increasing people's COLA. The reason people's COLA was increased because he increased inflation. Really. I think that's important to look beneath the rhetoric, because what is happening there is they are penalizing those, in terms of retirement income. And then he's done this woke attack. In this morning session, they talked about the SEC, and then there's in terms of requiring, retirement funds and retirement savings plans to invest, more in woke kinds of investments, rather than in a move away from the primary reason is to return a fiduciary, return, to investors. So they're changing all that. With ESG funds, certainly, they perform very, very poorly, in financial terms. And that's a major, major issue that was addressed this morning and really needs to be addressed. And we're certainly going to address it too. And what's good about this is Congress is stepping in to do this. So let me get down into, in terms of where we are. Biden's been disastrous for retirement investments. 401k balances plummeted 23%, some cases 40%, depending on who you talk to. So let's look at the buying power. And this is the punchline. So if you're at those middle incomes and lower income levels, that dollar you get is actually 42% less in value in terms of your buying power, which really puts you effectively back, to those numbers in the right column. From 53,951 of house median income, it actually effectively reduces it to 31,500 and some dollars. And then you go on down the line there. And that's what they have done. And it lies squarely with them. And it started, with the executive orders on energy and the spiraling of that, and it's directly affected investment by the oil and gas industry, because who wants to invest if they're trying to shut you down, and the politics of it is going to squeeze you even tighter. So here, look at the buying power here, in terms of those at the federal poverty level. You see those numbers on the left, that's the poverty level. But look what happens. Look what happens in terms of the reduction of those in the poverty level area. It is disastrous for them. And we have so many families, that are struggling, with that kind of thing. And so when I hear this administration and this president, talk about his commitment to the American people, that's nonsense. This is a Davos-styled administration. Their objective essentially, we fought their efforts to federalize state election laws and all of that. Their objective is to create a single-party oligarchy, federally strong, and suppress the states. That's the strategy, and they have lots of useful idiots running around in terms of the media, in terms of these causes, who are being absolutely duped. And I think we got into a little bit of that this morning. And certainly, the environmental issues that they are raising are absolutely false in terms of that. And we got a good taste of that tomorrow. So it's a big ruse. It's a question of, let's select those who should rule, and let's pick the winners and losers. And so it's sort of a wake up America time. And and here in this very granular example, in terms of what happens, in terms of the seniors and the safety net, look at the holes that they're poking in this. Increasing Medicare premiums, shrinking pensions, inflation, energy costs, crashing 401ks. So in summary, seniors live on fixed incomes, a combination of retirement savings, and those are being squashed due to the actions by, the third Obama administration, also known as the Biden administration. And it's got to be addressed, certainly in the Congress and that, and hopefully they're going to be tough. So, our CEO, AMAC CEO, Rebecca Weber, testified. And the closing line on this is, I think, very significant. It is not hyperbole to say the damage done to seniors' longevity, prosperity, and legacy by the Biden administration is the worst in the last 50 years. And that is our testimony. And so I would say to you, and I hope you all join AMAC if you're not members, and it's 50 plus, but actually it's 40 plus. So, and it's expensive, $16 a year, but we'll finance it for $1.25. So thank you very much.
Well, thank you, Bob. That was excellent. We had a rock star to start. I guess I got to give another one. We'll call you the classic rock star since you're AMAC. And it'll be followed by a country star who's from Texas, Margaret Byfield. Margaret and I actually met about, I'm going to say late 90s, early 2000s. We were doing some work on property rights, tangential to what we're doing at this conference, really taking on what the Greens were doing through the national parks, through their forest management policies that trample on farmers, ranchers, things of that sort. Margaret herself is from a cattle farm. And we had a chance, we kind of fell out of touch. That property rights movement kind of dissolved for a little bit. I guess it still existed, but then kind of reemerged with the Biden administration and his 30 by 30 initiative. Just out of curiosity, has anybody heard of that initiative? It's essentially an initiative, it's been rebranded now, America the Beautiful, to take about 1/3 of our country and make it into a national park. So anyway, we reconnected on that. Very oddly, I had aged my 20 years. Margaret has not. I look at her now, and my wife and I were having lunch with her, and I was kind of going, what's her secret? And she eats lots of red meat. I said, that's good. So even her diet is not climate friendly. Yeah, there you go. Well, Margaret Byfield serves as the executive director of the Americans Stewards for Liberty and is a natural resource policy expert with over 30 years experience. And her education began on the Pine Creek Ranch of Central Nevada, where her family became one of the first Western landowners targeted by radical environmentalists, resulting in a 27-year legal battle, and it's a famous one, Hage versus United States. Today, Americans for Liberty confronts policies eroding our constitutional rights, and particularly our Fifth Amendment property rights, and has been implementing strategies to defend these rights at the local, state, and federal level since 1992. So we welcome to the stage Margaret Byfield. Take it away.
Well, thank you. And let me start by saying it is great to have the Heartland Institute and CFACT as your friends. We did a summit in Lincoln, Nebraska last year on Earth Day, the Stop 30 by 30 Summit, and they both were co-sponsors for that event. But what really came in handy for us was a week before going into this event, of course, the environmental press started attacking us, and you know how they do this. They always attack you personally. They never talk about the facts. They don't want to have that discussion, so they attack you personally. Well, they made a very, very bad mistake because they named James Taylor as one of the speakers. And so James, I think within, I'm going to say 4 hours' time, had his rebuttal written and submitted to the Lincoln Star-Journal. And after a couple days of haggling, they did have to publish it. And it was fabulous. It was so nice to have the heft and the gravitas of James to step in and defend us and what we were doing. And I think when I thanked him, his response was, well, it's kind of like shooting fish in a barrel. And you know, that really summarizes the environmental perspective on all of this, everything that we're talking about. And because that is what their entire arguments are built on sand. Now, I'm going to talk about 30 by 30. But the science behind 30 by 30 is the climate crisis science. So they say we are in a biodiversity crisis. It's the same science that you guys have all studied. And let me say just up front, thank you, because you have already given us the arguments to help us fight 30 by 30 with the work you're doing. But that's the same science that we're dealing with to say that we must permanently protect 30% of the world's land and oceans by 2030. That's what 30 by 30 is. Now, this is an agenda that has been pushed on other continents pretty successfully, and America's a little behind the ball on it. But the European Union has their program. In Canada, they call it 25 by 25. They're trying to get there by 25. And it's worldwide. This is the agenda that America didn't really have to face until Biden was elected. And let me tell you, one of the first problems, and I think one of the reasons why it took the Biden administration to get this going in America is because there was a bit of a problem. In America, we're a little different. The people own the land. We, the people, still own 60% of this nation. The federal, state, and local governments and land trusts own the other 40%. So we are closely getting to where we're going to tip that. And why that is so important is because land is power. This is what the Founding Fathers understood when America was settled. We were a nation built on self-rule by we, the people. And it's more than just a document. It's more than great things on a piece of paper with our Constitution and Bill of Rights. How do we protect that? We protect that because the land is owned by the people. That allows us to control the natural resource wealth, therefore limit the government, limit their power, and each of us has the ability to have that independent prosperity. We mix our hands, our labor with the land, and we control our future. There's a reason that Karl Marx defines socialism, the abolishment of private property, because they get it. If they control everything, if they own everything, they can control us. This is what 30 by 30 is about. So I'm going to try and rush through this, and hopefully we can get some questions in the end if I miss anything that's not clear. I want to start with this publication, Center for American Progress. You might be familiar with this organization. They're they're a progressive left organization. Their entire agenda is to implement socialist policies in America. Now, 30 by 30 is a big part of their agenda. And they came out with this report in 2019, How Much Nature Should America Keep? This basically is not very scientifically deep or anything. There's a lot of citations, but it's still not very scientifically deep. What's important about this publication, it's the playbook. It is them telling environmental groups and policymakers, here's how we sell this program in America where there's this particular problem that people own the land, and we have to get that land. So this is their playbook. So let's start with, what do they believe? What do they advocate? So what they say is in the coming decades, over 1 million species are going to go extinct, and 1/3 of all American species. What is this based on? Models. I don't have to explain to this audience why that's bad science. They say we're losing a football field worth of habitat every 30 seconds in America. That's meant to scare you. They say 2/3 of the development that is occurring in America is occurring on private land. But only 1% of that land is protected. That's a problem. And only 12% of the total land in the United States is permanently protected at the level that they are seeking to protect 30%. So understand, the federal government owns about 27% of America. They're not talking about ownership, they're talking about level of control. Now, the first thing we started looking at this before Biden took office because we watched what the environmentalists were doing, what they were saying, and that's where we learned about 30 by 30. So we really drilled into it. The first question we had is, do we really need to worry about this? And you can tell by the people who are behind it. So we found this resolution that had been filed in the House and the Senate in 2020, and it's the 30 by 30 resolution. And it was only supported by 15 people across the two bodies, so it wasn't even a popular resolution at that. But what obviously drew our attention to it is who co-sponsored it. Then Senator Harris, and then Representative Holland. Representative Holland is now the Secretary of the Department of Interior, which controls and oversees most of the government-owned land in America, as well as a lot of the laws that impact private lands, such as the Endangered Species Act. So we fully expected we were going to be dealing with 30 by 30. Now, 30 by 30 was initiated on January 27th, 2021, in the Climate Crisis Executive Order. You guys will know this and remember this. 57-page long executive order. 2 paragraphs are devoted to 30 by 30, and if you didn't know what 30 by 30 was, you'd skip over this and get to the really meaty stuff. And what he says is that they are going to achieve the goal of conserving at least 30% of our lands and waters by 2030. Now, when we read this, of course, we knew what it meant because we'd been studying it. But even we wanted confirmation that what we knew as 30 by 30 is what they were going to be trying to implement. And we got it. That same day, Department of Interior issued their fact sheet explaining what they would be doing to implement this climate crisis executive order. And the section devoted to 30 by 30, you'll be familiar with the language. They say we're losing a football field worth of habitat every 30 seconds in America. That we're going to lose a third of the US species if we don't do this. And that only 12% of the land in America is currently permanently protected. So we knew exactly what they were doing. This was 30 by 30 as we had understood. So let's drill down into this. Let's get some facts. What is the 12%? They say 12% is permanently protected. Well, this comes from the USGS gap analysis. And the 12% is made up of our national parks, wilderness areas, conservation easements on private lands in perpetuity. That's how they get to the private lands, one of the ways. State parks, national wildlife refuges, national monuments, and some other restricted areas. The definition for what can be conserved, what qualifies, is for an area of land or ocean to be counted as protected. It must be permanently protected in a natural condition, and extractive uses must be limited or prohibited. This is land that we, the people, don't use. Here's a map. This is where all of that protected land currently is. This is the gap analysis map. The 2 dark green areas are gap 1 and gap 2. That makes up the 12%. The light green are other lands that are primarily owned by the federal government, but there's multiple uses on it. The gray areas are primarily our private property, which they consider unprotected because they don't know what's going on, or I should say, they don't control it yet. It doesn't mean that it's not being taken care of and that it's not well protected. That's actually, it is well taken care of. The National Geographic is one of the environmental groups that has been pushing this agenda worldwide. The article they did on getting this instilled in America was published in 2019, and they published this map to scale. The small box is the 12%, the large box is the 30%, where they want to get. Now, Governor Ricketts, I should say former Governor Ricketts of Nebraska, he's now Senator Ricketts from Nebraska. At the time, he said, this is the equivalent of protecting 1 state in Nebraska every year for the next 9 years, or 2 states of Texas. It's a lot of land. All right, this is the one that I really like. All right, so they say we're losing a football field of habitat every 30 seconds in America. That sounds pretty bad. Well, what does that come to? 3,000 acres a day, 1.1 million acres a year, and 11 million acres in 10 years. All right, let me give you some more numbers. 30% would be roughly 700 million acres of land in America. So they already have 300 million acres. What they need to get in the next 7 years is 400 million acres. But the problem, as they define it, at best, if you believe what they say, is 11 million acres. So the question is, why are they seeking to add 400 million acres in 9 short years, if the problem is 11 million acres? This is not about conservation. This is about control. Is private land a target? Absolutely. The CAP report goes into this and explains the way we get the private land is we convince landowners we're here to help them. help working lands become better, where the ranchers and farmers can do more to conserve water and land and species. And is 30% the end? Absolutely not. What this group is really pushing is the half-Earth philosophy, which you may or may not be familiar with. It was really pioneered by E.O. Wilson, a conservation biologist, who believed that half the Earth must be permanently protected in order to save humanity. Meaning half the Earth does not have us, humans, using the Earth. And in America, unfortunately, we have a lot of people working towards this half-Earth agenda, including the New Mexico governor, who signed an executive order in 2021 to implement 30 by 30 in New Mexico. But not only does it do 30 by 30, it adds 20% for climate stabilization areas. This comes out of really kind of the science piece, if you want to call that supports all this. Global deal for nature is really what kind of stands up all of these arguments. And Vermont, the state of Vermont, both the House and the Senate passed a bill to move the conservation of all lands to 50% by 2050. Fortunately, there was a Republican governor who vetoed that bill. But it shouldn't really surprise us because that is Senator Bernie Sanders' state. So he is, an admitted socialist, so it shouldn't surprise us too much. But the point is, this is happening in America right today. All right, next good question. Who is running the 30 by 30 program? That tells you a lot. If key people are in place, then we know we need to worry about it. Well, let's start with the co-chair of the 30 by 30 task force is the CEQ chairman, Brenda Mallory. Anybody want to guess who her chief of staff is? His name is Matt Lee Ashley. He's the author of the 30 by 30 report out of CAP, Center for American Progress. He is sitting in the key position to get this implemented. Another key person to watch, after the Inflation Reduction Act was passed in August, Biden appointed John Podesto over all of the as the head of the National Climate Task Force, which also oversees 30 by 30. And he is the founder of the Center for American Progress. So how is it being implemented today? Let me go over just a few quick things on how they're getting this done. The first is they're using the existing laws to implement this agenda. Key to understand about 30 by 30. In America, there is no congressional or constitutional authority for this agenda. It's done by government fiat. That's my time. Thank you. It's done by government fiat. So they have to use existing laws. And what they're really doing is they're taking our natural resource laws and they're changing the goal. So they have a lot of regulatory power and they're just basically changing the way they use that to get to the 30% goal. They're funding federal land acquisitions. They're really encouraging the enrollment in the conservation programs. They are handing money out to landowners and enticing them to get under the conservation programs like we have never seen before, increasing the price per acre that they pay to get landowners to set aside acres like in the Conservation Reserve Program for 10 years. They are outpricing and competing with the working landowner as they do this. And the importance of this is it creates, when you attach federal funding to private land, it creates a federal nexus. And there's a number of laws that come into play that give them a regulatory tool to start restricting that land. That's the danger of it. That's why they're pushing it. They're granting a ton of money to the NGOs, the land trusts, the Nature Conservancy, Ducks Unlimited. All of the land trusts are basically feeding at the trough right now because the administration is giving them tons of money. And their job is to go out and get the conservation easements put all over the private property. And wildlife corridors is another good one. Now let me give you an example of how this is being pushed in the West. After the Inflation Reduction Act was passed, the environmental community launched their campaign for the West on really how they see this playing out. It's called Rewilding the American West. It was first published in Bioscience to give it the color of being a scientific position, then picked up by Outside Magazine, and then, of course, pushed by the World Economic Forum. So you know that this is being pushed internationally. Now, what they're planning to do, the agenda, the purpose of this program, and right now it's just the environmental program, it's what they're pushing, is they want to create 11 districts across the federal lands in the West, 5,000 kilometers for each district that's going to be set aside. Where they're not connected, then they want to purchase the private land in between those and get the conservation easements on the private lands where they can to create corridors that go from Canada to Mexico for the wolf and the beaver. So they're going after the land and the water. This is their agenda, and if any of you guys have seen the Wildlands project that came out 30 years ago, this is basically a reincarnation of that philosophy. First that goes in these areas is livestock grazing, then mineral extraction, and then hunting and recreation, because they are eliminating all off-road vehicles. Now you look at that map, that's most of the West. Tell me how many people are going to go in and access that on foot. This is meant to make this part of the world with no humans. The other thing that happened, which we're going to be seeing a lot more of, is the Bureau of Land Management made the largest purchase of private land acres in the state of Wyoming last year, 35,000 acres. Now here's the kicker. Neither the governor nor the county commissioners knew it was even happening until the press release went out. This is what they can be doing in every community right now, and we wouldn't even know about it. All right, I'm going to step back a little bit. In the beginning, I told you that this is an international agenda and that they're much further in other countries than ours. Okay. In the European Union, they adopted what's known as Natura 2000. Now, what's interesting is when you compare the language to Natura 2000 to 30 by 30 in America, it's the same thing. It's here to help working landowners do more with their land. But now where we are in Natura 2000, after years of this being implemented, is the Dutch minister has determined that 2,000 to 3,000 landowners are going to have to voluntarily sell their land to the government to free up nitrogen credits because they want to put in wind and solar, and that takes nitrogen credits to put that in, and agriculture is taking too much of that. So they need the farmers and ranchers to voluntarily sell. And if they don't, then she says it's with pain in my heart that we will have to enter into discussions with a targeted group in which mandatory instruments will be used if necessary. This is what's coming to America with 30 by 30. They're just ahead of us, so we really have to stop it here. One more thing? Okay. I want to get to one more thing very quickly. I think it's really important. So in Canada, last December, they signed the 30 by 30 agreement, international agreement on 30 by 30. Now, let me just tell you what's in this. We knew that this was coming, but it's really a very interesting document. First off, it advances the worship of Mother Earth. Mother Earth, I think, is referred to in this document, I think 8 times is how many times I counted it. It's the only religion that is written up to be protected in this document. This is the worship of the creation, not the creator. It says that nature needs to have equal rights with humans. Requires urgent transformative action. And of course, it needs a lot of money to implement this, which is what they've all agreed to. Now, all the nations that adopted the 1992 Biodiversity Treaty signed this. The United States, the Biden administration was pushing this deal and was behind the scenes, actually and very out front, pushing this agreement. However, they didn't sign it. The United States did not sign this. And there's a reason why. Because in 1992, there were some colleagues of ours who were watching the Biodiversity Treaty and were able to expose that what they were really after was the Wildlands Project, the map that came out that showed that the true agenda was to push all the population into core population zones and rewild the rest of North America. And fortunately, these colleagues were able to get, very strategically, to get these maps in the right senator's hands, who went to the floor and said, this is what they're planning to do. Stop the vote. The treaty was never adopted in America. And therefore, the United States could not sign this treaty. But what you may not know is there were two key people involved in that got that done for us and has saved us today. One of them was Craig Rucker. So I guess the point of telling you that is all the work that you're doing today. I know it seems frustrating because you feel like sometimes you're just fighting against, sometimes it feels like you're spitting in the wind. But you don't know how powerful what you're doing today is and how 30 years later you could be saving us from something that could be very bad. Remember, truth is a sword. It's piercing. And it can cut through propaganda very, very well. So keep doing what you're doing. Thank you.
Thank you, Margaret. That was an excellent presentation. I had occasion to hear her give that in Omaha. And for those of you interested, there will probably be such a conference again this year that James was at, I was at, as we're trying to mobilize once again the land use opposition, if you could, to this takeover. I just want to underscore one interesting thing that she said, because there may be some confusion on this issue, and that's the genesis of it. For those of us who are old enough, this all came out of the big year was 1992, called the UN Earth Summit, put on by something called the UN Conference on Environment Development, UNCED. There were 3 big documents that came out. Well, there were 5 total. 2 of them kind of faded into oblivion, but 3 of them are with us today. 2 of them are mentioned in this conference. One deals with the Convention on Climate Change, which then grew into the Kyoto Protocol and then grew into the Paris Accord. The other biggie was the Convention on Biodiversity. They both came out of the same origin. There is yet a third one, and this will probably be the only thing that time it's mentioned, was called Agenda 21, which is now Agenda 2030. These documents are unifying. This is an organized plan from above that's decades long, and we're seeing the outgrowth of it in these different initiatives like 30 by 30, like the Paris Accord, and behind the scenes on the local level with things like Agenda 2030. All right, that's that. At this point, we're going to turn it over to you. And any questions that you might have for our assemblage of rock and country stars here. So go ahead.
My name is Ron Stein. Okay. This is a question for rock star Donna, and Bob may want to step in too. I'm from California. Governor Newsom has been pretty effective in getting California to have the highest cost of fuel and highest cost of electricity. And you stand by and you see the poverty population and homeless population exploding. And my question for Donna and Bob is, how do you get the people of color to stop voting these clowns into office?
I'm going to start. First of all, you have fair elections. You make sure you have election integrity. We actually put out a small primer about what election integrity means to Black America. They've been stealing Black votes for decades. And they've been harvesting ballots for decades. And black people are starting to speak up and saying, wait a minute, we shouldn't be voting this way. But I think the other thing is a step of courage, especially for people of color. When the media makes sure that they don't see a voice, the reason why you see them attack Uncle Tim and Clarence Thomas is because they're afraid that if African Americans see people like us come forward, then they go, it's okay for me to step outside of the box. But I can tell you this, the fastest growing demographic for African Americans that are going conservative are young black males. Start with them. Stacey Abrams did not win black men. And black men are the ones who are tired of being vilified, because what they've done with these socialist policies, I hope I finish quick. Sure. What they've done with socialist policies is made black men the enemy of the black family. So what we're trying to do is to unite the family. They built it into the tax code. They put asset limits on there. They actually penalize black people if you're in a 25 percentile and you get married without making a single dollar extra. They tax you 70%. We need to relook at those laws, because we should have credits that actually help black people when they want to be married, because you create a synergy and then you actually push people out of poverty. But what they've done is create a permanent barrier so that if two black people get married, then they take away their income, and so it's more of an incentive to stay apart. Go after black men in the communities, and then you can turn the community. I'm sorry.
Yeah, thank you, Donna. I fully agree with what Donna has said. Remember, wasn't it Biden that once said, "As how can a black person vote for Trump or a Republican?"
Yeah.
Because they considered that their voting bloc. I think, and you're absolutely right on trafficking. The media is a real problem here. Aside from Fox, which sometimes wavers, the other networks are really apologists, for the left and for the Democrats, and there's so much that they don't cover. The coverage is very, very carefully worded. You never get the other part of the story, and so people are misled. And where people's primary information comes from MSNBC, CNN, ABC, CBS, their understanding and perception, is really distorted. And not only in terms of apologies for the left and why in California, this governor is so good, but why Republicans and conservatives are so evil, and that's threaded throughout their coverage. And so, people need to learn and read, and I fully agree, because it's an insult, and they insult the American people, and they insult, black Americans.
Yeah. And go into the community. Conservatives don't go into black communities and talk, because they've already said that they're not going to vote for us.
Yeah.
One of the big problems.
All right. Now, can you please identify yourself, maybe where you're from?
This is Doug and Flanagan, and I have been with CFAX since you were a young man. A much younger man, I should say, since you're still a young man. But, it occurs to me that we look at those maps and we see that the large majority of these lands are in the West. Also in what you might call Republican states. And I suspect that many of the states on the east and the northeast do not have much land set aside. And so my first proposal is, yes, let's require every state to have 30%. And that means the states that have more than 30%, that land will be reallocated back to the people, and then take the land from those states that don't have 30% and force them to find a way to get rid of 30% of the people and things on their land. That'll be a lot of fun. The other thing, of course, is we are too timid. We have never started calling those, shall we say, those who control inner cities, like Mayor Lightfoot, for example, as Aunt Jemima's or Uncle Tom's. They're not, it's not the Tim Scotts and these people like that who are selling out black people. These are the ones who are selling out black people, and we're not afraid, we're too afraid to call them out on it. We haven't called them out on it, and we need to do it because we need to start calling them the things that they really are and stop letting them call our people who are honest and decent and helping black people emerge out of poverty the nasty names. I mean, Winsome Sears is not Aunt Jemima. Joy Behar, Whoopi Goldberg may be.
I agree with you on that one. We need to be more aggressive.
All right. Do you want to address, Margaret, the idea of turning the lands over in the East Coast?
The reason I looked over at Craig is we've actually had these discussions pretty recently one of the things we've done is we've pulled together a property rights task force, and we are dealing with all of these issues, and I'm very thankful James sits on that with us and Craig sits on that with us. But we've developed our first draft set of property rights principles that we're hoping to get a little bit more public as we get it refined a little bit better. But that is something that we've really discussed, is that one of the things, so right now 50% of the West is owned by the federal government. And what we do is we do a lot of work in the community. So we'll go in and help landowners, and we work with a lot of counties. And one in particular is Custer County, Idaho. They have 97% federal land in their county. They have to run their entire county on a 3% private land tax base. And everything that they do, they try to graze the land, mine it, take timber from it. It is just such a mess because they're dealing with the federal agencies and have to get approval for everything. And so it is the way to kill a community. The last conversation I think I had with the chairman there was he said he's starting to talk to surrounding counties to see what part of Custer County they want to take because they're going to have to split up the county. They have no tax base. But that's the model. That's what the proponents of 30 by 30, that's their idea of success. And that's why it is all about control. And so these are issues that we've wrestled with, and we're coming up with some pretty good ideas that we think are very practical, as well as ideas that we don't expect to accomplish in a day, but that we have a long-term vision and a set of goals and principles that we're going to be working towards for the next 30 years, although, Craig, you and I probably won't be here for another 30 years. But, that's one thing that our side does not...
We'll keep eating that red meat. That'll keep us there.
But that's one thing our side doesn't do very well. We set agendas for 2 years, and then we get our guy in office, and then we go back and we do what we like to do, what our real life is. But that's one of the things we're trying to change with this Property Rights Task Force, is set out that kind of an agenda that we can work towards for the next 30 years.
All right. Oh, yeah, that's
just
right.
One big point. Friends of mine in Utah tell me a sore spot with them is that when the state of Utah was admitted to the union, there was a provision in that would return the federal land to the state for a resolution in that. And one other thought on that. Years ago, I got to work with Phil Gramm on his very brief presidential campaign, but Phil's point was, why does the federal government need all that land anyway? Why not put it back into the economy?
Let me say one more thing, Craig. Do you mind?
Yeah, by all means.
So if you really want to understand what happened to the West, why the East is privately owned, and why the West became federalized, which is really socialized land use, if you go to our website, americanstewards.us, we did an article that we published not too long ago called Climate Crisis Robber Barons. And that gives you a brief history of how the West became federalized. And it had all to do with the robber barons of the industrial age backing the conservation movement at that time to cause the withdrawal of those lands so that those states didn't come in on equal footing, and the federal government retained that land, which it was never supposed to be in America, and it was the robber barons. And what we're seeing happen right today on 30 by 30 and all these issues is we just have a new crop of climate crisis robber barons, is really what they're doing. They're using the climate crisis as their excuse to push people off the land.
All right. Do we have another question? Go ahead.
Bill Balgord from Middleton, Wisconsin, and I would just like to register a complaint whenever I hear over the radio or TV or so on about consumer inflation. That strikes me, much of it, as being really a lowball. It doesn't begin to represent what we see in the supermarkets and so on. Case number one, the price of a dozen eggs. I've heard them say that it's about 30% up year over year. Try $5, $6, $7, $8 a dozen, and you'll be much closer to the reality of it. Is it not? I think the Labor Department that handles this. Is that correct?
Yeah, it's the Labor Department, and also, Bloomberg came out with that too, and I agree with you. I think that percent is really low. I agree with you fully. I almost took it out.
And the terrible thing is, it's really a regressive tax against middle and low income people because they have a disproportionate impact on their income. They pay the biggest brunt of their income. And it's just a way to make sure that you push people into poverty just like everything else.
And if I can amplify one of Donna's earlier points in terms of the lost jobs and the regulations are a tax.
Yes.
They're a tax that are imposed by unelected bureaucrats. It's the tyranny of the unelected, which and directly impacts, those folks that she talked about. But it's a tax on businesses. It precludes businesses from even starting or growing or surviving.
Hi, thank you guys so much for being here. I'm learning so much, so thank you. I have two questions. The first question is specifically around how do we kind of get people to understand the language. I feel like that was like a prominent theme throughout the presentations, when you guys were showing us the legislation, showing us, what was being passed, the facts, et cetera, because, I was reading something the other day that basically the average American reads on a 7th to 8th grade reading level. So, it is probably even, who knows when the last time that was updated, and, with our school system and curriculum and the way that it's going, it's probably getting lower and lower and lower. So how do we get, minorities and people that are on these specific reading levels to understand these bills that are being passed? And the follow-up question to that would be, and once we do, I guess, get there, how do we create this sustainability plan and, maintain that? Because I also realized too, when you guys were presenting that, yeah, it would be amazing, right, if we elected someone in office that would come in and, implement these policies and, get work done. But then, we have election come around and someone comes in and then, they can reverse the whole entire thing. So just wondering your thoughts on those two things.
Well, I'll start. The majority of urban communities, especially on the left in liberal states, is actually at 4th grade reading level.
Wow.
It's not, and the reason why a lot of the states weren't won is because people were talking over them because they didn't realize that the reading level was that low. So when you're coming in, you have to talk plain language. Make it simple to where they understand. If you go in most urban cities, climate change policies today have created home ownership rates that reflect the 1960s Jim Crow. Communities are more segregated in places where they are advanced in creating these climate change policies than they were during Jim Crow. People understand that part. So if you come in and you start talking about the science and critical race theory, the 4th principle of critical race theory is that people of color don't understand scientific method and legal reasoning. So just talk plain. How does this affect? How much does this cost? When someone says to me, have some sympathy, my first question is, how much does this cost? The other thing is, low-income people think every day about money. They worry every day, all of their lives. When they wake up, they think about money. When they go to sleep, they're thinking about money. They're thinking about how they're going to pay their bills. Translate what's happening into why they're paying so much money or why there's a barrier for them not to be able to get a job. They killed those pipeline jobs. Guess who had to pay? I don't agree with Jesse Jackson, Al Sharpton, or the president of the National Urban League. But you know what they said? These decisions are being made without asking anybody in our communities. We don't think poor people and people of color should pay the brunt of these climate change policies. When these people say this, talk to them and make them a partner so that they are the ones that go back to the community and say, hey, you know, we need to not support this agenda that they're having. Al Sharpton and Jesse Jackson actually supported a pipeline to go into a rural community in the state of Illinois. So they're there, but we say the left is evil, and then we leave, but we don't say anything else. Yeah. When they're asking, they're not saying like we're attacking you. They really do want to know, how can you help?
And you know, it's interesting, Donna, is that the left is actually sensitive to this.
Yes.
Because when I was at the Egypt meeting, I think Alex Newman, if he's in here, he was there as well. One of the big concerns they have is that there will be pushback in minority communities and even among seniors and even people in rural areas to their policies. Their solution, they've already thought ahead on how to handle that, is to give them government money to cope with their green agenda. And they are actively doing that. In Canada, it has jacked up the costs as they've gotten rid of the oil sands in Alberta. Their solution, give paychecks to everybody to help them pay their electricity bills and get them more dependent on the government. So that'll be our next challenge as that seems to be the route that they're going. We have time, I think, for one more question.
And it's a biggie. Hi, my name's Peter Morecambe. I live in North Carolina. Back in 1866, we had leaders that were real leaders. They put in the Homestead Act, and they gave away $180 million of federal land. Why couldn't we? We've got $200 million to give away now, so why don't we do that? I'm British, obviously.
You don't have to apologize for that, but you're not getting your tea back. All right.
Okay, we got it. There we go.
Oh, do you want, are we through? Our time is okay? Okay, go ahead and answer.
Do you want me to go ahead and answer? Well, so, I mean, I like your idea very much. And that's one of the things that I think is a message that is so important to get across, is that, and this getting to the educational issue too, I think one of the things about the new generation and how they are being taught in the schools, we have to understand they're not being taught to think analytically. They are being taught to think emotionally. Everything is, how does it make you feel? Not what is truth, but how does it make you feel? But I think that one of the things that I found connects with audiences, and I've actually given this very same presentation, or very similar to this presentation, to an audience not too long ago that was 90% Democrat. And they were with us because they made the connection that if you have the ability to own land, it's property. If you have the ability to own land, which is what we were intended to do. So the Louisiana Purchase, when Jefferson made that purchase from France, it doubled the size of our nation at that time. He did not call up Bill Gates and say, how much do you want? Or China. He opened it up. It was disposed to the states. The states, depending on which Homestead Act they were under, anywhere somebody could go out and stake either a 120-acre homestead or a 640-acre homestead. And this is what built the middle class in America, because every person could go out and own a piece of land. And what did that do? That meant that that family could grow their own food if they had to, could build their own shelter, could defend their own shelter, and then could mix their labor with the land and produce and build their local community, make it a strong economic unit, which then built the state, which then built the national economy. That's how it was meant to be. And that worked. I mean, that absolutely works. And I think that if you can make that connection to people of how important it is that we own the land so we can control the government and restrain their power, because we own the natural wealth, the government doesn't. The government doesn't have a way to make its own living. If we can do that and we maintain that control, then we can restrain government and increase individual liberty. And that's where this has to go. So I love the idea. It's definitely something on the Property Rights Task Force that we have been talking about, and we've actually drafted some stuff to kind of hopefully move the nation in that direction. It's a big lift, but it's an important lift.
A historical antecedent to that were discussions between President Reagan and Margaret Thatcher, and particularly believing that if people had home ownership and owned real property, they wouldn't be going to the streets and rioting. And from Margaret Thatcher's perspective, as you would probably know, Northern Ireland was such a place. And President Reagan also during his administration really promoted home ownership, as a way of lifting people up.
I was going to say one thing. If you want to turn minorities off for universal income, tell them that they're paying you not to own land. They're paying you not to be able to own your own property, because that's always a restriction.
I'm sorry we're going to have to end our session here, but let's give a round of applause to our rock stars. You can hold up your lighters if you want, but they're not doing any curtain calls here. So thank you for coming, and enjoy the rest of the conference.